Okay.
Okay. Well, welcome to the January 7th, 2025 session of HamSCI and TAPR technical session. My name is Dave, KV0S, and this week I've been um, figuring out how to install the OS on some of the compute module fives, which is not as straightforward as I originally thought, but it was successful. So thanks to and big help to Dave Whitten. So that's it for me. Otherwise, I'm cleaning boxes in my basement. So we're trying to consolidate and get rid of lots of boxes that I have hardly anything in them. So next on the list is Nathaniel, W2NAF. Go ahead.
Thanks, Dave. I had a very nice New Year's and Christmas. So it all went very, very well. I'm very glad to be back. Right before then, I had gone to the American Geophysical Union meeting, and I took 8 students, and Bill Engelke was there, and a number of other people, and that went very well. So we had a good success there. A lot of my time, right before break, I wrote the annual report for the GRAPE 2 project with Case Western, got that submitted to the NSF and accepted. I'm now working on, I now have to write the final report for the Daisy 1 project, so that's in progress. And I'm also, I did write a work plan for myself this semester, which includes some plan of what I need to do for the Daisy 2 project. So that's coming along. But one of the things I'm trying to do is I'm trying to ask my university for additional time and resources to support what I'm doing. So if that at all, I've been writing a lot of documents to try to justify all of this. And so if any of this turns out favorably, I'll let you know. And if it doesn't, you probably won't hear much more about it. So we'll see what happens. But otherwise, things are good. I'm very excited to hear how people have been doing. I'm excited to hear updates on the antenna project because I know a lot of emails have been going back and forth on that list. So back to net.
Okay. Next on the list is Dave Whitten, WD0EAG. Go ahead, Dave.
Hello. I've mostly been hiding in my basement, trying to stay warm and avoiding avoiding. It's really not that bad out here, but everybody's in a panic as always with the first snowstorm, and I guess I let them. I honor that paranoia, but by staying out of their way. But I'm not a lot that's really exciting to report, I'm afraid.
Well,
So,
I wanted to compliment Dave. He was able to pick up a project at Tepper that other people had not been able to accomplish. And we got a new set of EasyDV boards in and are on sale at the Tepper store now. So thank you, Dave. Next on the list, we have Dave New in 8 SBE. Go ahead.
Yeah, hi. I've been gone for the last couple of weeks. I think maybe there was also a hiatus in this Zoom meeting as well, so I don't think that I missed a whole lot. But we were actually went up to Calgary, Alberta for Christmas to meet our new in-laws because my grandson essentially was married in a private wedding ceremony in their living room on December 27th to their daughter. So we had all kinds of things keeping us busy up there. And we flew back into Toronto and got in at 2:30 in the morning here. The plane was delayed about 6 hours, and then drove back to Ann Arbor the following day. So it was kind of a marathon. but anyway, so I'm glad to be back and glad to be back in the Zoom call, and I'm still operating as a fly on the wall, as they say. But I'm certainly learning a lot by listening to what's going on here. Thanks.
Oh, very good. And glad you enjoyed your trip. Uh, Next on the list is Phil Karn, K9Q. Go ahead, Phil.
Hey guys, yeah, I've been busy in the last couple days, going back and reworking a lot of things, and of course, I always run into problems. I did proper sample rate conversion in my monitor program, and then deployed it in all machines I had access to. And then this morning, Rob tells me he's having problems with some Ubuntu machines that don't seem to have the resampling library that I'm using. This is a common problem. I always think long and hard when I'm about to introduce a new dependency in my package because of exactly this kind of problem. But other than that, I've reworked the monitor program. It's a lot cleaner now. It sounds a lot better, especially in the presence of packet loss. And I'm really pleased with it. Let's see what else I've been doing. Like on PCM record, I think I'm pretty much done with that. Rob is now using PCM record to create his files that he then processes into processes by Whisper Daemon. Let's see what else I've been doing. I guess that's about it for the last few days. I am interested in hearing from Nathaniel about HFDL since he was around when I talked about it. I remember asking you, Nathaniel, if you thought this might be useful, and you said yeah. So, well, okay, now you have it. What do you want to do with it? Tell me, what should I do with the data?
Oh,
You can look at the video for more details, but basically it's sounding data on a whole bunch of frequency bands across HF.
okay. Maybe
Uh,
we can talk about it more in the open session.
Yeah.
Yes.
That
So,
sounds
Yeah, that's
great.
about it from here for the last week.
okay. Next on the list, we have Scott Newell, N5TNL. Go ahead, Scott.
Hey, uh, well, I guess I tried and failed to grab SAQ, and then I tried and failed to do the Russian FMT. So I followed that up with sending Phil some pull requests, and I made some mods to the web stuff. And that's about all for me this week.
Well, glad you're there. Next on the list is Andrew. Andrew's phone. Comments?
Hi, thanks. Nothing to report, just hanging hanging out and listening to what everyone's saying. Thanks. Happy New Year. Back to net.
Okay. Next on the list is Bill, N8FET. And it's been a while, Bill.
Yeah, it's been quite a while, actually. I thought I'd better come back and see what's going on. But last month I've been busy. We had a fellow in the club that died, and he willed all his radio equipment to the radio club. And we went out and picked it up. It took a day to get it all loaded in the cars and trucks and brought down to the club. We literally filled the club up, front door to back door, floor to ceiling. And I made a list so that we could all bid on it. And it was about 650, 700 items on that list before I quit. There's still more I discovered that I got to get listed on it. And it's taken me the last month to get this distributed. I've still got some to go, but that's keeping me heads down since about the 1st of December. So today's the first day in a long time I haven't gone in to look at it. So it's been quite a journey. And there's still a pile of stuff to get rid of. So anyway, back to you, and I'll sit and listen. Thanks.
Oh, okay. Next on the list is Bingham. Any comments, Bingham? He turned his mic on. I'm not hearing anything. Well, we can come back to you if you have some comments once you figure that out. Next on the list is Clint. Go ahead, Clint.
Okay. Hello. I tried detecting SAQ, listening remotely from northern Utah, but wasn't able to even detect anything. But one of the hazards is since it's a mechanical alternator, the frequency is 17.9, what, 2 kilohertz plus or minus 5, 6 hertz. So you can't use too narrow of a bandwidth. Anyway, so, but I haven't been able to detect anything from the file that I created. One of the other things I worked on, finished them a couple days ago, or some, well, one of the problems is I'll bet you no one using RX-888 on HF has properly integrated it with 6-meter reception that's going to do it justice. So this is a, so you can, let's see here. This is a 6-meter preamp and filter and post amp. And it uses a Norton lossless feedback amplifier because we have a kilowatt FM station only about 2 miles away from where the SDR site is. So the first stage is roughly filtering it is down by 10 dB at FM, but low loss. And the Norton amplifier, it's, has maybe about a plus 40 dBm intercept ratio and extremely low intermod. Then the next filter actually has a notch that's about 80 dB deep at the FM frequency of that station. And then there's another 13 dB gain amplifier because you need a crap ton of amplification on an RX-888. You need about 20-ish dB or more to make it hear the noise floor in a quiet site on 6 meters. And then to bang it together with the HF port, it's a diplexer, and it's just not too many components, but it'll take the existing HF spectrum and bash it in with the limited 6-meter and amplified spectrum, and then with that we're hoping we will get a usable result and make it worthwhile sampling at 130 megahertz. And we're going to install that, hopefully going to install that this coming weekend up at the Utah SDR. And we'll see how that goes.
I think John Ackerman would be interested in what you're doing.
Yeah, I mean,
I noticed that one of the KPH receivers is running at 130, and I was able to hear Paul's beacon. That was it.
right. I mean, the 888 alone, if you have a low noise, if you're on, say, an Omni and in a low noise location, you're probably 15, 18 dB from the thermal noise floor, I'm guessing. You have to look.
It's pretty bad.
I mean, yeah, the 888, I did see a thing on one of the, I don't know if it was the HamSCI group, or somebody is asking or making a comment that their Kiwi was working better than their 888. And, assuming the 888 was crap, that might have been JJ Phil. And I think the big difficulty is with the 888, everybody's chronically underdriving it. And in generally speaking, you're better off slightly overloading your SDR frequently than underdriving it if you want to pick up more what's there, especially on the higher bands.
So that figure is with full gain, I assume, and no attenuation.
Well, I presume. Well, yeah, no attenuation.
Okay.
I don't know what Phil has set up, but the 888 isn't is not is like 4 or 5 dB short at least of the Kiwi.
Yeah.
So
I don't use the attenuator for anything. I just set it to 0.
oh,
I mean, it
the
doesn't seem useful.
attenuator and the attenuator in the 888 it is as useless as that thing on a Warthog, right? I mean, there's absolutely no reason for it to be there. I challenge you to find a situation, a general purpose ham situation, where the attenuator would ever be useful.
Yeah.
It is absolutely has no useful function whatsoever. Anyway.
But it has its own insertion loss, which worsens things.
It's about a dB, supposedly, according to the Skyworks data sheet for that part. It's probably, I don't think it's that high, but it's worse than useless for most hams.
Yeah.
Anyway, but yeah, we can talk about that later.
Okay. Well, next on the list we have Dave, W6OQ. Go ahead, Dave.
Hey, good evening. Good evening, everybody. So yeah, holidays were good. here I am back trying to work on my to-do list. That's about it.
Well, good. Glad to have you back. Next on the list is David McGaw, N1HAC. Go ahead, David.
Good evening, everyone. I hope most people, I guess, had some time off. I did not. Dartmouth had their 2-week break, but that was time for me to be moving out of my primary lab at Dartmouth. I don't intend to, it's not my intention to retire, but it is my boss's. And so I have to move out of the lab. And it's a lot of work, not yet done, but I've been in this position for 18 years, so you can imagine what's accumulated. But it's an interesting archaeological dig. Let's put it that way. And becoming perhaps more a citizen scientist than a professional at this point, but we'll see where things go. Back to net.
Okay. Next on the list is Dick. Any comments, Dick? He's still got his microphone muted. Nope. Next after that is Gary, AF8A. Go ahead.
Yeah, good evening, everyone. Welcome to 2025. A couple of weeks ago, I was happily listening to National Public Radio, their weekly science or daily science show called Shortwave, and I heard a reprise of a story about the South Antarctic Research Station singing Christmas carols to one another. And it was once again glad to hear Nathaniel's voice, but I'm not sure if that was a complete repeat or they added the stuff at the end about the Santa network at the end. If that was new, I'm not sure. But
Well, I can tell you that the first part about the Antarctic carols was a repeat. The second part about the Santanet was new. In fact, W3USR landed on the front page of the Times Tribune the week I was at AGU, because they wanted to do a story about talking to Santa over ham radio, and it was quite an amazing spread. And I was able to pass that information along to the NPR reporter, Emily Kwong. Um, Unfortunately, they aren't actually transmitting the songs from Antarctica anymore. I did get in touch with the research associate down there, Shelley Campbell, who I had known from a couple of years ago when I was at McMurdo. So she's still there, just working in a different position. And she said they're not doing the carols this year, which is unfortunate. But they still ran the story doing a repeat. So that was kind of cool that I was on. Um, and the other thing that is nice is I am back in touch with Shelley Campbell down at McMurdo Station, which is good since we are, believe it or not, Robinette, and we are full speed ahead on trying to get a Whisper Demon receiver type thing down at McMurdo. So that is going to be that's on our project list for this year. So the tentative ship date will be fall of 2025 for installation this coming field season.
awesome. So good. Yeah, it was great hearing your voice again on NPR.
Thank you.
Let's see, just a bit of advice. Maybe I'm just behind a little bit, but I tried to make my reservations for the Dayton Hamvention in my hotel a couple weeks ago, and the rooms were all booked up. And I usually book in Springfield, Ohio, about 15 miles away. That's the same Springfield that gained all the unwanted notoriety during the presidential election. And they were booked solid. And it's possibly because Wittenberg University is holding their graduation on the Saturday of Dayton Hamvention. So that's kind of unfortunate. So anyhow, if you're looking for rooms, I don't know if I would wait too much longer.
Yeah,
And
that's a good suggestion.
yeah, so and my other accomplishment this well, for me, I guess it's Christmas break every day, but I did build a QRP Labs 10-meter whisper beacon. So I'm now beaconing on 10-meter whisper. So I got to join that bandwagon a little bit. So got some more work to do with it, make a GPS discipline, but at least it's up and running. So that was my fun and game. So back to net.
Okay. Next on the list is Jay Schwartz, WB8 SBI. Go ahead, Jay.
Okay. Howdy, everybody. Happy New Year, everybody. Um, Nothing good here, basically, for the past 3 weeks. Um, I've been dealing with a very, very sick relative, and that's just taken up my whole time. Over the break here, I got to be on the air once on 20-meter FT8, made a handful of contacts, but this family situation is absorbing most of my time here. Nathaniel. Um, this past New Year's Eve, the Space Weather Woman had her annual New Year's Eve online everybody welcome to join webinar. So I asked her if she was going to be available or would like to come to HamSCI this year. Unfortunately, she will not be able to make it
Wow.
because of the fact that she has been commissioned for a big video production project on space weather. And she indicates that this is going to take up most of her time this year. So between the day job, this project, the family, doing her YouTube and Patreon things, that she just does not have the time. So no Space Weather Woman at HamSCI this year. Oh,
I can certainly sympathize with her trying to make time for everything.
yeah. So otherwise, nothing new, spectacular, or exciting here. I hope everybody else had a good holiday break. Uh, and take care, stay warm. Back to net.
Okay. Next on the list is Joe, W7LUX.
Good evening, everyone. Thanks to Rob, I've got myself one of these field probes, and this is what it looks like working with the little tiny spectrum analyzer. And nice bright light up there. I can turn the light off. But anyway, it's about 10 dB of increase. I've hauled this thing all around my property. Makes almost no difference wherever I try. Signals are all roughly the same, so I don't find any advantage in doing anything. And I've also got one of these RX 888s. I put in the big thermal heat pad to help dissipate heat. And so far it hasn't burned up, which is a good thing. But when I run it with HD SDR, it seems to work okay. But when I use SDR console, the SDR console quits every, I don't know, a few seconds to 12 hours. It just stops working. Don't know what the problem is there, but kind of discouraging. Anyway, just 1 or 2 degrees above freezing here in sunny, well, almost sunny northern Arizona. Thanks, Dave.
Yep. Next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. I don't have a lot in terms of VLF news other than we had a very successful reception of SAQ on Christmas Eve. Gary, big thanks for decoding the message. I deeply appreciate it. Both messages. Gary actually tried to. I applied some more filtering, and Gary also did some more filtering and enhancement himself, and he was able to decode almost all of the December 1st transmission, as well as fully decode the Christmas Eve transmission. So Gary, as always, big thanks, and I will get the draft article back to you very soon. I don't know if well, for those who might have noticed on the HamSCI Google group, that I was able to, I had a very successful reception of SAQ on Christmas Eve. I posted the MP3 file of the recording, and I also posted a filtered version of that using socks. So what I did was I used a Butterworth filter because VLFRX Tools has a brick wall filter. and obviously at the edges of that brick wall filter, it could be hard on the ears, let's say. So a Butterworth filter is much easier on the ears. A notch filter is you know what I'm talking about. And I was able to get I was able to get pretty good reception. There was still some background noise. It was a good amount of fading, but it was definitely intelligible and decodable. And thank you, of course, Gary, for that. It came time to renew my or in other news, it came time to renew my amateur radio license for the first time 10 years ago. I believe about a week from now, 10 years ago was when I first got licensed. So that was actually quite exciting. And thank you to all, especially Nathaniel, for the license upgrades that happened in the past couple of years. So that felt pretty cool to renew my license. Nathaniel, there were a couple things that I wanted to talk about. Hopefully, we can kind of fit those in the open session. The first is that Frontiers paper. I was unsure of whether I would be doing a whole paper or I would be contributing to part of it, in which Gareth Perry and Christina would be involved in writing. I don't know if they're involved in writing or if they're editing or you know, but I would like to talk about that because I would like to make an outline.
Okay.
Because I'm not really sure what the topic should be.
Mm-hmm.
But I had planned on talking about the VLF system and VLF-RX tools and what can be done with building a simple VLF system with VLF-RX tools and all the research or all the data products and everything that can be done with that. That's what I had planned on, but I don't know if there should be if topic should be adjusted or not.
Mm-hmm.
But I was my girlfriend Lori keeps on pushing me to make sure that I submit the paragraph by the end of the month. So I want to I don't want to disappoint her.
Well, I would be more than happy to talk with you about that.
Oh, okay, all right. And the last thing you mentioned an installation date fall of 2025. Was that in Antarctica?
Yes, that would be for the HF system. A small HF system that we would ship down there
Oh,
to
okay.
McMurdo.
Is it would it be too early to like would it be possible to ship a VLF system down there at that time or?
I'm uncertain, but I will tell you that it's not out of the question. Um, what what we are going to be starting this semester is we're going to be starting conversations with the research associate down at McMurdo Station and with NJIT to understand what is down there. And we will have a chance to kind of re-architect, you know, to basically design what we want to send down. So you can certainly be part of those conversations and we can see if it's feasible to include a VLF system. If not, if we don't send it down this season, you know, even possibly next season, but we can start, you know, trying to design for that.
Okay. All right. Yeah. Because if it is feasible this season, then I'm gonna I'm gonna um, get started and try to kind of push everything to completion to the testing phase and where it could be actually sent down and installed.
Okay.
So that'll definitely give me definitely give me motivation to get everything done within the year. But again, obviously, Antarctica is a challenge. So
Yeah.
yeah, include me on those conversations. If if there's a possibility, and then
Yeah.
we could kind of develop an action plan and move forward, and then
Yeah. There definitely is a possibility. And I need to sit down and um work with you more because we have some, we've actually written you into these grants, especially for the Daisy 2 project, and we need to get you onboarded for that.
okay.
And that is it's currently a work in progress. I am working with the dean right now to try to get myself more time to handle all of these administrative tasks. I'm
Mhm.
also trying to get more administrative support at the university to help me handle these administrative tasks as well. So it is absolutely on my radar, and we are working on it. If you once the semester starts, well, I'll be in touch, but I mean, I typically am available, Thursday evenings at the radio club.
Okay.
But we can get in touch about, I'm working on my schedule and stuff like that. So,
Okay. All right.
yeah.
That's fine then.
Yeah.
Yeah. Yeah.
And
Because I was I wanted I if because I did want to at at least kind of figure out this frontiers paper if this
yeah,
is a feasible thing to do, and
yeah,
also
yeah,
if it's feasible,
yeah,
the the
yeah,
the system down in Antarctica, and that would be, I think, a good engineering exercise,
yeah,
because if we design for that,
yeah.
um,
A really good starting point for you, and actually this is something you can really help with, is
yeah,
if you if you can talk with David McGaw to find out what is down there already, because a lot of the stuff that's down there, some of it's Jim LaBelle's. So
yes,
we need to understand what's there and if any of that is usable. So that's kind of a starting point.
okay,
So
yeah,
I do have a little more energy and time tonight than perhaps usual. So after the open session, we could probably talk more this evening if you still have energy too.
okay, all right, yep, that'll be fine.
Okay, that sounds great.
All right.
Okay. I wanted to catch a couple people. Bill Engelkey came in. So, Bill, go ahead.
Well, good evening. Thanks, Dave. Not a whole lot to report. Just playing with this new Flex 8600, which I got right before the holidays, a sort of a Christmas and birthday present to myself. It's pretty cool. It has a GPS disciplined oscillator and what they call adaptive pre-distortion, so you can't splatter no matter how hard you try. So that's good for contests and things like that. So anyway, not a whole lot else to report at this time, so back to Nick.
Okay. And then we also had Paul Elliott uh, come in. Go ahead, Paul.
Yeah, hi. Hello, everybody. Yeah, I've been busy with family and, over the holidays here, so I haven't been able to participate. Good to see all you guys again. Um, Not a lot. I just wanted to, couple things. Joe, you'd mentioned the RX 888 crashing. I was curious, if some of these SDR programs allow you to change the clock the sample clock rate. I mean, I was wondering if it's not an overload of, the USB interface, and the ability to handle that fire hose of data, and if you were maybe able to reduce the sample rate, maybe that would fix the problem. I don't have any personal experience, but I've seen what other people have been encountering, so that just came to mind. As far as if there's an opportunity or a desire to stick a whisper sond down at McMurdo, obviously you don't want it particularly close to your receiving site, but McMurdo's a pretty big place there. Let me know. I'd love to help support that. I've got whisper sonds available. I don't know when, deployment as far as, the HamSCI deployment is planned for, but I'm ready to support it. I've got like 4 of them ready to go right now, and I could easily have more of them pretty quickly. I've also got an updated filter combiner that I'm really liking as far as its ability to handle oddball SWR, which sometimes in some of these installations we have antennas that maybe you're trying to push an 80-meter signal through a 40-meter antenna, and some signal's better than no signal at all. So I've got a combiner that at least it doesn't try to cook itself when you run 1 watt through it with a horrible mismatch. Also, I'm really close to sending out for a new filter preamp design that is optimized for, that extends up to 6 meters. And I've tweaked the filtering on that so that it actually kind of has a notched out area in the FM, 88 to 108 megahertz band, because that's been talking with people that are seeing FM interference, aliasing back down, because the 888 front end filters just are not that good. So anyway, that's stuff that's coming up, or I've already got it. So, if anybody needs this or wants to talk to me about it for deployment or, development thoughts, I'd love to hear about it. And yeah, over the week, over the Christmas holiday, my grandson came down with pneumonia, which but he's done his antibiotics and he's feeling great now. So that worked out okay, but it kind of occupied our time for a while. Anyway, back to Annette.
Okay.
I will say that I would be very interested in getting a whisper sond down at on the ice. And I think one of the things that Gareth Hyoman and I have talked about was getting more amateur radio support down in Antarctica. So I think that's something we'd like to talk about more.
Okay. I'd love to take a trip to Antarctica. I've been there kind of a cruise ship, small cruise ship thing, and it was amazing. So if you need any ham help down there, let me know. But
we
other than
just
that, any support I can provide from up here
yeah,
in the
I
continental
can't.
United States, I'm happy to do that too.
I can't make any promises, but we can. I've had ideas of. Well, we'll talk some more. But
Okay.
Can I interrupt for a minute because I
Yes.
need to step away to
Okay.
go into another meeting. But
Go
I
ahead.
have a whole discussion about Antarctica, and Gwen is working on a proposal to deploy systems with a collaborator at 2 Australian Antarctic stations as well as the British ones, and that's proposal is going into the Australian Antarctic Authority today.
That's
So,
awesome.
so that would be that would be receive only. Now, I have a lot of other stuff to talk
Rob,
about, but I got to
why
go
don't
to
you?
another meeting. So I'll be back.
Oh, okay.
Okay,
Well,
Ken. So hopefully I'll be back within half an hour or so on.
okay.
But I got a lot to, as always, I've got a lot to talk about.
Yeah.
But
Well, when you get back, you can talk about it.
okay, I'll be back.
Okay. Next on the list We had, let's see. Oh, um, oh, there's another person. Doug jumped in there. Uh, Doug, any comments?
I've just joined. Sorry, I was late for this, but I don't have anything new to contribute.
Well, welcome
Thank you.
and hope you find it interesting.
Yes.
And next on the list is Tom M5EG. Go ahead, Tom.
Oh, good evening, Dave. Everyone, is the audio okay?
Yes.
Oh, thank you. Got another video up over the weekend, getting started with KA9Q radio. Part 5, which a headless Linux server, and a lot of views on it already. The first 2-3 days, there's been about 75 or so views. So I think folks folks like it, and that's about it. Back to the group.
I've watched it and it's quite nice, Tom. Appreciate it.
Thank you. And Scott, thank you for your fork of the SDR, the spectral display. That really works great.
Okay. We also have Tom Yarnish. I don't know if he wants to make any comments or not.
No, I don't. But it's Yarish,
Oh,
Y-A-R-I-S.
sorry.
Yeah. I am a fly on the wall. I'm tearing down my office. I'm doing an archaeological dig, finding amazing things under 12 years of dirt grime. So I hope to be reconstituted in a little bit and fully functional, but it's kind of disgusting what I'm finding here. Projects past and past lives, past wives, stuff I've forgotten about. And so that's all I have to share. I'm kind of working behind the scenes with Rob and some of the other groups, guys here in Sonoma County on the Whisper projects. And I don't have much to report. Just always enjoy seeing you people. So Happy New Year to everybody.
Okay. Well, if I'm correct, I think I've called on everybody and we're ready for, we need to get back to Rob when he gets back here, but we're open for general discussion.
That sounds great. Do we want to start with Phil and the HFDL?
Sure.
Yeah, we can do that. Basically, I've got the data. Now, what do you want me to do with it?
Okay.
Well, do you
So
know what it is,
no,
Nathaniel?
I don't know what it is because I wasn't on the last few calls. So
Okay.
Basically, this is HF data for airplanes over the water and
okay.
or over, Arctic areas or whatever. Although I see a lot of it over the U.S. too. And there's a huge amount of overhead in this data. I mean, it's rare to see a packet that actually has user data in it. But the interesting stuff is the ground station beacons its location and what frequencies it's transmitting on. The airplanes find those, find the strongest ground station, and they start reporting which ground stations they can hear and their own locations. They also report, packet statistics, how well they've heard everything on the ground. And it seems to me that because the airplanes are moving here, you could get a lot of propagation paths over places that hams don't go.
Hmm.
And it's either a work or not work path. It doesn't give you any precise scientific information, but it could tell you, just who can talk to who and when.
So is it when you say it's a work or not work path, so it's kind of similar to like RBN or Whisper or something like that if you're just ignoring the SNR reports and
Right.
yeah.
Well, I mean, there
But
are reports of, okay, how many packets were received, how many were in error, that kind of thing. I'm not sure how to turn that into a quality number.
right. Yeah, no, it sounds very interesting. I think you're right. What do we do with the data? Um I think me personally, I'm saturated at the moment. But um we certainly can put it out there for someone, you know, we can write a little we can you could write a little blog post or Gary can help you write that. We can put it up on hamsci.org. You could see if anyone's
Okay.
interested on it on the hamsci
And a
Google
lot of
group.
people have been receiving this. I mean, I didn't write
Yeah,
the software to do the decoding,
yeah,
but I probably the first one to do it on like all channels simultaneously, which is the
yeah,
cool
yeah. But I
part.
mean,
There's something like a
if you want to
dozen
have
stations around the world, and one of them is
yeah,
KFS. KFS is the receive site for the San
yeah.
Francisco one.
If you want to write something up and have Gary promote it on the HamSci list or whatever, then maybe
Okay.
someone might want to do something with it.
Okay.
And
Yeah, I can
and then
probably
and then
extract some of the messages and
yeah. And
if
it
they
might
need.
get folded into some of the work that I'm doing eventually. It might get folded. We have our postdoc Kukai. She's actually working on another proposal right now, doing ray tracing and HF model validation using RBN Whisper and that sort of thing. She might be interested in the data. Um, so we do have some of those people as well. So
I will mention 2 weeks ago, Bill had it running and you can see the data coming in
yeah.
off the radio. So you can get a sense of
Yeah.
what the data looks like. It's all
The
text data.
No, the other thing that might be interesting that we might fold it into is we have a project starting up that's sponsored by the FRC, the Frankfurt Radio Club, and that's to create some sort of a DX dashboard for the personal space weather station. And the goal of this particular dashboard would be to use what's received by the RX 888 and somehow turn that into a real-time usable information for someone who cares about either DXing or contesting. And um, perhaps, so I have a freshman student that I want to start off on this project, and he'll also be mentored by FRC members and, other people who would like to help mentor him. But um, you know, I'm basically going to show him the different data sources that can be that the RX 888 is providing, and then he's going to start making displays out of it that can tell you something about where you're receiving from. So actually, this might be a good value added information to that display because um, these planes may be located in places that amateurs are not located, and so it
Yes.
may give us paths that we may not otherwise be aware of. So that might be really useful for that.
And this is I just showed here the log that's
Yeah.
running already KFS on KFS Omni, and
Yeah.
all the data is going in one big file. See the kind of messages that are here. Um,
Okay. And
you
these
know,
are on, yes, I see it's on like 10 megahertz and
yeah, they
Panama, New
change it, of
yeah.
course.
York.
Yeah.
It
5
changes. The
megahertz. Okay,
transmitter
yeah.
for San Francisco is in Dixon, I believe, the old VOA
Yeah.
site
This may be
in
very helpful
Sacramento.
for this DX dashboard project that we're looking at.
Yeah, I think for a DX operator, I think the most interesting thing would be my own, FT8 and Whisper scraping or hard or skimming,
Yeah.
because it shows you what you can hear right now with your own antenna. Now, I don't know, what do the rules say about DXing and contesting about using SDRs to receive when you can't hear them yourself?
It puts you into another category sometimes, but there's a lot of contests that accommodate that. Most of them, as a
Yeah.
matter of fact.
The
They
other
allow that
thing,
or do not allow it?
They do allow it.
It,
There's a,
if
so
you're in
you'd be
like an
okay.
unlimited category or
Yeah.
yeah.
but
Yeah, but of course, if you prohibit it, it'd be pretty hard to police, right? You
yeah,
can't really detect that kind of cheating. Um, so anyway, I
Phil,
mean, if people are motivated to hear with their own stations, I mean, my stuff would be a good tool to do it. Of course, we're all feeding that data to PSK reporters, so you could find out just from there, who can hear
Mm.
somebody and go there if it's a public SDR.
Yeah. Well, I,
but
I think, and I do think, certainly starting with the Whisper and the FT8 and things like that is what I imagined we would start with. So what I was going to have the student do was basically start learning the RX 888 and the K9Q radio and Whisper Demon and try to develop, architect some sort of a visualization for that.
Well, you can
But
start by
yeah,
looking at, PSK Reporter and
yeah.
Whisper, that org, and so all that stuff, and get some ideas.
Yeah. So I'm actually meeting with that student this Thursday. So we're going to be actively starting that project this semester. So there will be a lot more chance to discuss this. But
Okay.
that looks very helpful. So yeah, I'll keep this in mind, and yeah, still work with Gary. Feel free to promote this and let other people know that you have it there. I think that's great. And then I'll, as I can figure out ways to fold it into the projects I'm doing, we'll do that too.
Yeah, right now it's getting logged. We're not doing anything with it, but it's being logged.
Yeah, that's fantastic. That might also be useful for uh the Antarctic receiver too.
Yeah.
Yeah. Yeah.
Yeah,
There are some receivers in Southern Hemisphere, like Cape Town and so forth.
yeah.
Australia, even though New Zealand, I think. So, of course, it's not covered as well as the Northern Hemisphere.
Right. Okay.
Plus, you can just see, which ground stations you can hear at any given time. These are all propagation beacons. There are about a dozen of them, and there are a bunch of different frequencies.
Yeah.
So you can also just look for, who you can hear.
So the HF, so these are specifically supporting aircraft?
Yes, this is for commercial aviation.
Hmm.
And it's an extension of ACARS, if you know what that is. It's a
Hmm.
VHF message system. It's pretty old.
Yeah.
This one's been around since the 90s, I think. Uses a single carrier modem. And dug into it and found some papers that say actually it was not a very good choice. They did a OFDM modem and compared it side by side, and it worked much better. So I guess that means if I'm going to play with modems on HF, it means OFDM.
Yeah.
This is the only single carrier HF modem I know of that I'm using.
Hmm.
Pretty wild to listen to. Sometimes these channels get very busy. But it can tell you things like it can tell you for sure that a link is not there. With hams, if you don't get a report, it might be simply because the ham is not on the air or is using his,
Right.
radio for something else. But here,
Right.
they're giving negative reports, they're reliable.
Right.
When it
Yeah,
says they cannot hear something, the station was transmitting and the receiver was listening and did not hear it.
right.
That might also be useful.
Yes, I completely agree with that.
Like that one just went by right now. Of course, you got to know which stations what frequencies the stations are actually transmitting on. They have a complete list here, but they only use a couple of them at any given time, depending on
Hmm.
propagation. But you can get that list too.
Hmm.
So yeah, the negative reporting might actually be the most useful part of this.
Right, right. Yeah, I agree.
So anyway, I'm just an engineer, I like to build the stuff and throw the things at the scientists, let them figure out what to do with it.
Yeah. Yeah,
You're,
that's
you're the
I
scientist, so you figure out what to do with it, what I've come up with here.
I think if you can write a little summary document, I guess, or a little blog post. I know that
Okay.
you gave a presentation on this a couple weeks ago. I'm uploading those to the YouTube now. You can do your little write-up, and then Gary can
Okay.
create a direct link to
There's
the
a lot of
YouTube.
blogs and tutorials already about
Yeah.
HFDL itself. I don't need to go into much detail. I guess I could just point out the parts that would be useful for propagation research.
Yeah, that would be perfect.
Yeah. Because most people receiving this are interested in tracking flights. We could do that too, but lots of other people are already doing it. I don't know of anybody using it for HF propagation research.
Yeah. That looks great, Phil. Thank you.
Okay, sure. Actually, I've got it running on all four antennas at KFS. This is just the Omni antenna. So I'm generating actually 4 times this amount.
Yeah.
So anybody got anything more interesting than a scrolling screen? I'll turn this off.
I'll be happy to talk to Jonathan about the paper.
Okay.
If Jonathan, are you there?
Yep, I'm here.
Yeah. So, yeah, so Gareth and Christina are basically convening a special issue of Frontiers. So they're like serving as guest editors. Um, so what I would, and they basically invited everyone that they knew did something about the eclipse and, citizen science and things like that, including you. And I think you writing a paper would be a great idea. And I think the Frontiers papers, their research papers, are can be fairly long. Um, yeah,
No. Nathaniel, you're breaking up.
okay,
Your
I think
video's
it's
frozen.
probably my Starlink connection.
Ah.
Yeah. So the Frontiers standard article length is fairly long, so you have a lot of room to play with. And I think, now that you've been running the station a couple of years, I think you could write a nice article that basically says, here's what you made, here's why you did it, and you could lay out the design, and you have like a methodology kind of um more engineering section. And then um at the for the second part of the article, you could do 1, 2, or 3 different examples of some of the observations you've made, you know, either for the eclipse or some of the other interesting observations that you've shown. I think you write that up, and I think it'll make a very nice article.
No. All right. So I have so I would kind of start it off. I would introduce what I built,
Mm-hmm.
why I wanted to build it,
Yep.
all the technical engineering part of it,
Right.
and then the various different observations made with the system.
Mm-hmm.
Should I include so that would make like a good outline.
Yeah.
But after the observations,
Mm-hmm.
should I do something like looking towards the future, or
Mm-hmm.
because then ultimately what my goal would be is to have obviously multiple receivers,
Yeah.
um, and a and and use and leverage this network of VLF receivers to provide lots and lots of research data.
Yeah.
So then that would be like um, uh, not phrased like looking towards the future, but future ideas maybe.
I think that sounds really good.
All right. Yeah, I don't think that there's like any other topics that I would fit. I would say that's a pretty solid outline, because that was pretty much what I had planned on doing, was um, doing something about the system, and uh, the outline makes sense.
Mm-hmm.
So then, so then I'll do the outline, I'll write the paper,
Mhm.
and then so then Christine and Gareth and the other two, they will be the editors of the paper.
Well, editor, when we talk about scientific journals, editor is usually just the person that makes the decision of does it get accepted or does it not get accepted.
I
So,
see.
so the editor there doesn't really mean someone who's actually saying change these words or change those words. What happens is you write the manuscript and then you submit it to the journal. It gets assigned to an editor, and then the editor will send it to some anonymous reviewers that they believe are qualified to provide a proper review of the paper. So the editor will generally have some reasonable knowledge of your topic, but they
Mhm.
may not be a subject matter expert in your particular topic. So the
Right.
editor's job is to go solicit a volunteer reviewer who does have qualifications to review the paper. That reviewer will then read the paper and they're going to make comments. They're going to say things like, uh, we see there's a, they may ask questions, why did you do this over here? Or I see a problem with this at this particular line. And they'll generally split it up into major concerns and minor concerns.
Right. Okay.
And then what they'll do is they'll send it back to the editor, and the editor will take a look at the two or three reviewers' um, reviews, and then the editor will make a decision. Their decision can be return to you for revisions,
Mhm.
reject, or accept. It's very, the most common thing is that it gets returned to you for revisions, and then you
Yeah.
have a chance to revise it based on what the reviewer said, and you do that, and then you go back and forth and one, maybe two rounds of revisions if everything goes smoothly.
Kind of like what happened with your Frontiers paper.
That's exactly the process.
Oh, okay. Okay.
It's the exact same thing.
I see. Okay. All right. So then,
So what I would recommend, I would, you know, I'd recommend that you be the first author of this paper, but
okay.
then perhaps you pick out, if you have a few people that have helped you, I would volunteer to be a co-author. And so I would probably help you actually, um, I would be the first round of making suggestions. Okay, why don't you do this? Why don't you do that? You know,
Okay.
and then you might pick some other people here, like, Dave Larson has significant academic credentials and he's written more than one paper in his time, and
Right. Right.
so he would have, and there are other people here that you might consider adding as co-authors that could really contribute to helping you improve the paper before you actually submit it. But you'd be the first author, so you'd get the primary credit, and then you could have the other people help you along.
Okay. Okay.
I
Um,
I wanted to jump in here. I have one question that I would probably ask.
yeah.
So you're collecting data with the site at Nathaniel's farm. What kind of aggregation, if you have more than one site, are you planning or do you envision? Because
That,
that's where the data becomes more useful when you have more than one site.
Mm-hmm.
right. So the plan is that I was going to run either a server at home or on a cloud somewhere, and it would be accepting uh, VLF data streams from each of the receivers.
Yeah. Now
There's
we do actually have funding in the Daisy 2 project to aggregate it all onto the University of Alabama server.
yes,
Yeah.
yes. Mm-hmm.
So I mean that, so it would be really useful for you to tie in what you're doing here to that grant
Yes.
because that's going to do a couple things. One, it's going to you now have access to these additional resources like all of University of Alabama's computing resources and their programmers. And you also have access to, this could be the first paper that gets published, before it gets deployed to everyone. So you can imagine that in this Daisy 2 process, we're going to be deploying these out to these other sites. People will be asking, well, what does this thing receive? Well, we can point them to your paper once it gets published.
Ah, okay. Okay.
And then it also looks good for the grant too, because the grant, we have to be able to report on the grant. These are all of the papers that were published as a result of this grant. So if we tie what you're doing into the grant, then it justifies why we got the funding to deploy all of these things.
I see. Okay.
So I just mentioned that Rob is back.
I am back. I don't want to interrupt anything. I'm now. I was off asking the Half Moon Bay Amateur Radio Club if they would host an account so that we could accept contributions down at KFS for the KFS equipment. So we'll see what they can do. Anyway, my primary activity has been recently has been working with Phil's code to do 32-bit float recordings. And I do have that running. And the results are as I expected. It really doesn't make much difference to have these 32-bit float samples versus 16-bit samples. But there's about maybe 0.5% more. You'll get eight over a few hours. You'll get 1,890 spots instead of 1,881 spots. It's a very small improvement in spot count. But the purpose of it was to ensure that we get data into the grape server, the 32-bit float, so we don't have to deal with AGC because it's bedeviled me. There's too many sites have too much dynamic range. I mean, they're diurnal changes of 30 to 35 dB of overall signal level at a site. And while you get a 90 dB dynamic range out of a 16-bit sample, you're now consuming, a quarter of it or a third of it of your dynamic range is just accommodating the range of signal strengths you get across the day. So that basically eliminates AGC and eliminates any of the processing overloads in the processing chain. So there's a few wrinkles. It's still not ready for release, but I think this was an important feature for the DAISY and the grants, especially for our recordings of WWV, so that we can ensure that the recordings reflect the complete dynamic range across the days and weeks of the WWV carriers in the recordings. Right now, those carriers are, those recordings are limited to the limits of the 16 bits int samples. And if you look at those, much of the days, you will see the samples are way down there in 100, the value of 100. And then you'll see in the middle of the day, it'll go up above 16,000 and above the top of the chart of the spectrogram. So I haven't yet started to deliver those float samples. They're still going to be 10 hertz wide. They're still going to be 24 hours long, but the samples themselves will now be individual samples in the recordings will be 32-bit floats. And I think it should be someplace in the DRF. There's someplace, I'm sure, to indicate the format of the samples that are coming in. So um, that's, I'd say, 90% done, of the way done with the 32-bit float project. And thanks to Phil for his support, both in outputting the floats and for his enhancements to the PCM record program, which captures those and puts them on a series of wave files. So the other thing I may have to say, it's more like I'm monitoring it than I'm working on it, is the antenna project. There's been a lot of work. Glenn has organized a group of beta testers, um, and we have been working through a bunch of issues. Um, at Right now, the primary beta test is happening at Michael's AC0G's post. He has one of Glenn's single antennas. The SA is what we call the antenna, and if it certainly outperforms everything there. We're not sure how much it outperforms because there's still the antenna and especially with Scott's really important enhancements to the K9Q web program. We are now able to see things that we actually, Glenn, who is the designer of HP spectrum analyzers, is saying he's seeing things now through Scott's new web program. Glenn is seeing things he's never seen before, impairments he's never seen before. So this is Scott's work is a major contribution that I don't I just he's too modest in his description, but he has really helped us in general, and in particular, this is an essential contribution, I think, to us establishing the quality of the DAISY 2 receive sites. I mean, you can see very clearly at Michael's, you can see in the medium wave band, you can see 10 and 20 dB elevated noise levels above what he should have at Quiet Rural. And we have some insights into what the sources of those impairments. So even if we don't end up using the single antenna, we have, through this process, I think, beginning to establish a methodology for deployment and analysis and monitoring of the DAISY sites to ensure that they're actually delivering the best radio reception reports and recordings and they continue to deliver them over time. So all of the credit really goes on that project goes to Scott, who has been working closely with Glenn and with Michael, the three of them, and I guess someone who hasn't joined us, but I've mentioned before, Elmer N3AGE has also been working very closely to test out the mechanics of putting up a vertical dipole of this sort. So we've got 4 people working really hard and very productively on the antenna system. And even, as I say, even if we end up choosing the DX engineering, we now have the tools to know that what we're actually listening for isn't the local noise or the ground loops in our receive sites, but in fact we're listening to the signals that are being presented to the antenna that we've established there. So that's I mean, I don't think many hams appreciate how much better their receive sites could be if they have the right tools and the right techniques for analyzing what's going on. And the field probe is just one element in that process. It's one element of the technique for establishing a receive site. So I think we have a team working on this, and that we will have quantifiable results in the near future. Now, um, the next site I would hope we would I think we might want to do is your place, Nathaniel. But we need
Yeah.
to, but this is not something you just throw up in the backyard. And
No,
this is not okay.
and
You need
I'd
to
like to do
invest
it when it's
time.
not 10 degrees outside too.
Yes. Well, yeah, but
I mean, would perhaps I would love it if you could perhaps come visit here, maybe when the weather is better.
yeah.
And I think we could perhaps have you, you know, work with our students and visit my site and work with our engineers. And I think we could make that a very productive experience for,
That's we
so
might
maybe
be yeah,
maybe
that'd be great. Yeah,
maybe we could plan that for like late spring or early summer or, you know, something like that.
yeah, that'd be fine. That'd be nice to
Yeah.
nice to
Um, I think another thing is Gary still on here?
Yeah,
Yes.
I'm here. Yep.
It sounds like what we're learning from Rob is that some of the information that we're getting from him and some of these techniques may be important when we're choosing sites for our deployment. What what do you think about that?
Yeah, the trick is, obviously, say we get 100 volunteers for 30 sites.
Right.
Is then you need to winnow those down to the best 30, I guess.
Mm-hmm.
And do we have people use one of Glenn's active probes and a nano VNA to walk around their site and report us back the results? We give them a thumbs up or a thumbs down. I'm not.
perhaps, or perhaps if they, if they have an SDR and an existing antenna, that we just start by saying, let us remotely log on.
Yeah.
We could send them a little, a 888 and I'm hoping an Orange Pi, and just have them plug it into their antenna. And we could log on and look at the spectrums and look at what we're seeing at their site, what they have, what they exist, if they, if they exist. I presume most of these people who are offering their to host a site, most of them already have some kind of equipment, receive equipment and antennas in place. So I think this is all, we haven't really gotten to this stage. We're still learning about,
Yeah.
what process we to go through. But I think it's pretty, I think that having some device that would be easy for someone. You mail it to them. They say,
What
plug this into the wall, plug this into your antenna, and then we can log in and we'll take a look at it and talk with you while we're. But it has to be really easy. I mean, it has to be something that doesn't require any knowledge of Linux or any knowledge of, or computers or any setting up of firewalls or any of that. We have to, it has to be that simple. And I think it can be. I mean, the remote, I use the remote access channel features of Whisper Demon. I'm on people's computers all the time, across the world. So I have a facility that service that I've implemented could be part of this and would give us immediate and direct remote access. So we're not talking about, well, what do you see on the screen and what does it sound like and all that kind of stuff. You don't have to do that, okay? And um, we'll send them a little package that has a MiFi that logs on to the local Verizon hotspot. Just power this thing up, plug it in this wall wart, plug it
Yeah.
into your feed, give us the feed from your antenna, and let's talk. Let's see how good it is. That's what I was hoping would be the site evaluation methodology. That
And Gary, we wrote, if you put your project manager hat on for a minute, I know that we wrote in the grant proposal that we would deploy all of these things year one. There is no reason that we have to do that. We have a tremendous amount of flexibility over the 4-year period of the grant, plus a 1-year no cost extension at least to get to do things right. So if we want to say make a goal that we're going to deploy, 2 or 3 sites this summer, and we're going to kind of nail down this procedure that we're going to use for site evaluation, and we're still in, choosing between these 2 different antennas. I don't see any reason why we can't, use the time this spring and this summer to kind of try that out on 2 or 3 different sites, get that down, and then prepare for a larger deployment year 2.
Sure,
Well,
sure.
well, I'm hoping that we would have the evaluation kit if we were. I'm describing that we could, this is
Yeah.
a 888 and an orange pie and a MiFi. So we're talking about a little,
Yeah.
a pretty easy installation and a low cost piece
Yeah.
of equipment.
Which I
So build several of them so that don't do one at a time. Let's do 4 or 5
No,
of them.
but what I'm saying is we don't have to spend all $100,000 on equipment year 1, rush things out, not have things done well. We can take a little bit more time, make sure that we get our procedure right,
Yeah. Well,
you know.
we need to, I think we have another month or 2 of
Yeah.
working with, with Glenn and others working, and Elmer and Michael working on the single antenna.
Mhm.
But we can start doing evaluations as I've described as soon as I could get the orange pie to work properly,
Mhm.
or we could just a larger box, put a B-link out there, and that works just fine. But anyway, some small little thing that if you have, Gary, if you have candidates out there that that have already volunteered, I think we could start doing site evaluations in the
And
next
that's
couple months, and do that. At least do a couple or 3 or 4 of them at a time. And
If we had the hardware, we obviously got to have the hardware.
well, I will procure and assemble the hardware and configure it so that I'll
and you can talk to me if you need some support for that hardware. So
yeah, I would
that's
like that. I would
yes,
would like
like
to get
that's I mean that's absolutely the sort of thing we should be supporting. So,
yeah.
you know,
Yeah. Well,
so that's
I've got a batch of 4 888s that are all modified and working.
great.
So I'm, I'm ready to, uh, I know what to assemble. I just need to finish a couple of other, I've got, things, I've got to finish the software and I've got a few other, projects going on in parallel. So,
Yeah.
but, and I think that, but I think hopefully that we could be in this process, and I'm ready to be a part of it. I know with Michael, is now fully capable of supporting, these remote evaluations. So there's at least 2 of us who know how to go through the evaluation process, and I think that we might be able to recruit a few more after we've done a few of them. Maybe we can get a few more people. But we only want 20. We want 20 sites, right? So it's
Yeah.
not like, if we had 2 of these, and each evaluation takes 2 weeks. Well, that's 10 weeks of, and mailing time and all the other stuff. So
Yeah. And how much does each evaluation kit cost?
I'd budget, I don't know, $500.
Okay.
That's
Yeah.
that's basically, it depends whether I want to, if depends whether I want to put it, GPSDO, the evaluation kit. Does it really need to have be GPS stabilized? Probably, it isn't. That's really not necessary for a good evaluation. It's if we're going to do Doppler measurements, we do, obviously we not need that accuracy and stability, but for site evaluation, I don't think we do. And that simplifies. You don't have a GPS antenna that you've got to put outdoors someplace,
Right,
just.
right.
And I was thinking I'd get some of these little MiFis, and I think you can run MiFi that so that we don't have to talk to their network in the house. They can just
Yeah,
plug the whole thing in, and it calls home on its own and without
yeah,
any interaction. So
yeah, I
and
like that.
yeah, I really needs to, this needs to be plug this into the power, give us RF into this jack, and
Yeah,
just leave it on and let us, call us up and tell us it will know. I'll know when it comes online, of course, because it'll log
right.
in. But that's all that would be asked of these sites, and then we could take a look at it. And then if they want to, if we say, oh, this is good, well, it's a good candidate site because you already have a good antenna, then we don't have to, we can say, okay, whatever antenna we decide on, it's certainly you have a good, we know that they have something that works well.
Yeah,
So, um, but already. So, but I do think that if we want to, well, the larger there is behind this question is, do we want, to what extent do we want all these sites to have the same kind of reproducible characteristics? I mean,
right.
uh, if we do, then we really need to have the same antenna systems. Uh, if if that isn't a high criteria,
Yeah.
then we don't people
Well,
that have
according
decent.
according to what we wrote in the grant, the stations that we are funding are supposed to basically have identical hardware, and they're kind of our standard candle stations. So
Okay. Well,
the ones that we said that we would actually pay for with grant money are
uh-huh.
supposed to be a little higher quality than, what
Yeah.
someone who's self-funding might be.
Yeah. Okay. Well, then, then I think there's going to be an antenna that they have to be ready to. That's be almost the first thing I would ask them is, are you prepared to deploy and guy and, and repair if necessary an antenna on your property?
Yeah,
And it's going to be a vertical. It's whether it's a DX engineering or the single antenna. These
right.
are these are posts that are, you know, 10 to 20 some feet tall. So you have, someone has to have the approval of the powers that be, and the has to accept that this antenna is going to be added to the uh, uh, to the panorama of their home. So I think that's a process that can be started. I don't think we should wait too long because I think we will have all the other components working by this summer, one way or the other. If we, the only thing that I have to do, I haven't done is to see if I can get the Orange Pi to work instead of a B-Link. So. That's the only uncertain piece of hardware at this. We know that the DX engineering is a decent antenna. It's not bad. So but it's like any unbalanced antenna. It's very subject to local ground and other conditions. The local environment really affects a antenna like the DX engineering. And in contrast, the single antenna is because it's a balanced antenna, is not subject to such I mean, it still has there's some local effects. The grounds always have effects on it, but it's not nearly so great as it is with the DX engineering. But we have yet to determine that, uh, to what extent. There's the benefits and costs associated with the use of the single antenna. So that's the antenna project. I mentioned briefly before I had to step aside that I'm also Gwen has engaged with Dr. Bulger, I think is his name, Jerry Bulger, in the UK, who has extensive contacts in the Southern Hemisphere, both within the Australian Antarctic Commission and with the British Antarctic group, as well as several amateurs, one of whom is on South Georgia Island, and another on the Falklands, and another one on Ascension, I think. Anyway, Gwen is working with them, with Gerald to, he has prepared a proposal. Gwen has prepared a proposal which Jerry is submitting to the Australian Antarctic Commission. Was supposed to be today, Tuesday in the UK. Well, I don't, well, anyway, whenever there's almost 24 hours of time zones here between me and Gwen and Australia. So I don't know exactly when it went in, but it was going in the next day or two. That document, I think, is being submitted, I think would be very valuable for you, Gary, as a template for to give to prospective sites, and it describes the scientific motivation, who the organization HamSCI. I mean, Gwyn is doing this as a kind of a HamSCI project, although I don't think he's necessarily expecting HamSCI to fund these sites. I think, of course, it would be nice if you guys would consider doing that, if we could fit it within the grant to do so. But whatever we end up, there's these could be, they would be in essence, it would at least be the 888 and the receive site that we have now. It won't be single antennas. It's just that we have to, we know the difficulties of the Antarctic environment and antennas, and one single antenna isn't going to survive, and probably the DX engineering might not survive there either. The one that you sent up there, that went up to Ellesmere Island, seems to have survived. It's not a particularly good antenna. It's hard to tell because so much of receive site performance is there's so many factors that go into to its performance. So it's pretty hard to tell, especially with that QTH. We have no reference receive site, no site comparable to. No, we're getting spots, but mostly on high bands, but you can see, he's VY0 ERC is contributing spots to WhisperNet and elsewhere, um, continuously. So we do have experience up there, and that loop that you bought and set up there is in place and working, Nathaniel. So
That's good.
So we have pretty good now. We have pretty good experience with that. We do have some experience with Antarctic operation. And it's a lot of it is the operational issues. I think, Paul. I think it's the Whisper Sound is running there. I haven't been monitoring it at all, though. Have you? I don't know if you've looked at the Whisper Sound up at.
I looked at it a couple days ago and I wasn't seeing anything coming out of it. But to be honest, I'm not sure. I'll have to go back and see. I remember there was a deal with which database was Whisper Rock looking at, and I'd have to check and see, because if the transmit and receive has got the same call sign, then it doesn't, one of the sites doesn't report the transmitter, figuring it's listening to itself.
WhisperNet will reject.
I'll have to double check.
Yeah, you have to
Are
look
you
at
talking about just the last few days, by the way?
For me, it would be the last. It's been within a week, I think, that I've looked.
Yeah, because just to point out, there's an ongoing proton event, polar proton event, that is absorbing HF.
Oh, that may be it. I think I was seeing some other activity up there, though. So, I think maybe the Whisper, but not the FST4. I don't know. So, yeah, I guess the short answer is I don't really know. I haven't seen the activity, but there may be reasons other than propagation or equipment failure for that. It could be database issues.
Well, let's see. I got two reports from VY0 ERC in the last week. Two spots. Maybe what was all bands, all modes. Geez, two spot reports in the last week. That's pretty poor.
Let's look at FST. I'm curious because I think no, well, wait, that's 1 hour. So yeah, no, it's something I'll start digging into a little bit more. Because for a while it was, coming in loud and clear. So I hope
It might
that
be in
nothing.
my conditions. Here's the application. Here's the last month of
Yeah,
so it looks like
1226.
up through the 10th we were doing really well.
Yeah, I'm seeing
Since
stuff as
nothing.
no more recent than 1226, but I am seeing
Well,
that.
I see one from today, PF8
Huh.
JZA. This is
Which
this
mode?
this that's we're choosing to call them phantom spots.
Yeah.
There's a whole nother subject we could spend the whole night on, which has to do with phantom spots. There's a there's a group, Jim Lill, A2ZKZ, and Phil, who runs this Whisper.rock site. Phil, VK7JJ, have been deeply investigating um, hoping to find the source of these phantom spots. Unfortunately, it seems that one of the sources is the Michael, our Narita, our silent key. His transmitter is still on, and it appears that his transmitter may be stimulating sites to generate phantom spots.
Okay. Talk me through this. Is his transmitter running FST 4W?
He is, um, I believe so. I think I believe so.
And
I can like, yeah.
these are phantom whisper spots?
Well, I haven't had time to look at it. I did
Okay.
the one case I saw, which was your 6 meter transmissions from
Mm-hmm.
Occidental, line of sight to KPH on 6 meters. So you were the only transmitter, and you're transmitting 4W.
Yeah.
And until December 14th or so, every 10th whisper cycle or so on, you're transmitting every cycle. And every 10th cycle, there would be your 6 meter 4W spot reported and a whisper 2 spot reported at the same time, at the same frequency, with an R11JXZ call sign very consistently. Now, I based upon that, I theorized that 4W's transmissions were being misdecoded by Whisper 2. But since the Whisper 2 decoders, but since December 11th or 14th, there have been none. So
And
I wonder.
when did the cache or whatever it is get flushed? That
Well,
the
this is
data.
another whole. Yes, we're another thing we're learning about the quality of Whisper data is very much a function of the quality of the hash table.
Yeah,
And
right.
I don't know if people understand how Whisper works. The Whisper decoding works. There's two stages to decoding. There's first a Fano decoder, and I should let Phil describe this because he wrote it, I think, or at least the original implementation
Yeah, I
of the
wrote the
Fano.
version Joe Taylor translated into
Okay,
Fortran.
yeah.
Phantom decoder is basically solving a Sudoku puzzle. It's walking its way through a very large tree, examining branches to see if they work. And then each branch is defined by a decision of a hypothesis about what the next transmitted bit was. And if a guess is wrong, I mean, nothing's going to work. I mean, the regenerated sequence is not going to match the one that's coming in. But as long as it does match, it's going to keep moving forward, and it'll move forward quickly, assuming the signal is very high, has a very high signal-noise ratio, won't make very many mistakes. It'll be like a very easy Sudoku puzzle, and it'll reach the end very quickly. But if it gets noisy, it'll backtrack and have to explore a lot of sub branches before it finally finds the right one. Now, normally, because the constraint length of the encoder in Whisper is so long, it's 32 bits. That's a lot of states. The tree expands pretty far before it becomes a trellis. In fact, you just treat it as a tree. And the usual assumption is that you put a limit on the number of operations that this decoder can make, the number of times it can backtrack and explore other paths. And as long as you limit that to a reasonable number, the decoder will never reach the end on a garbage packet. It will simply fail to decode. It's called, failure to decode is called an erasure. You don't know anything about the packet. My hypothesis all along was that the Whisper daemon users are running this thing with a very high limit on the number of decoder
Yeah.
back
Yeah,
moves
that's
in
your
order.
that. Yeah, but I don't think that's it. Yeah, but that's
Let
not.
me let me let me get to
Yeah.
that. Yeah, because
Yeah.
there is this fundamental trade-off in information theory between error detection, error correction. When you have a very large block of data, it's very easy to get a lot of both. I mean, if you get the data you'll get the data if at all possible, and it will be correct, or you'll get nothing at all. The problem with very small messages, like in Whisper, and the message is like 50 bits, is that that boundary becomes rather problematical. As you turn up the gain, so to speak, to try to get more and more messages out of the noise, you also increase the risk of getting false decodes. And there's nothing you can really do about that with such a small message. It's kind of just inherent in the probability. So my advice all along has been stop trying to, maximize your spot counts and get to every last spot out of it, because that is inevitably going to start creating false decodes. I know there's another stage of decoding I don't fully understand that apparently always produces a decode even on garbage. And if it's appears to be a type 2 Whisper message that has a hash in it, and that hash is in a table, it will issue that as a successful decode. Is that right, Rob?
Well, there are two stages, two attempts at decoding. My understanding from
First,
Gwen
I
is that
found a decoder, right?
there's the Fano, and then if that fails to find something, then they apply this ordered structure decoding, OSD.
Which
And
I don't
apparently,
understand, and I don't see how
I
it can
don't,
really
and
work better.
okay, but anyway, so Gwen says the OSD decoder always produces a packet. It always produces something. And then the Whisper D decoder then goes and looks and says, okay, here's the call sign field of this thing that I've just decoded. Is that call sign present in the hash table? And if it is, then the Whisper D treats that as a valid packet. So my understanding of this is, again, Whisper, it's the first pass, the Fano decoding. The WSJTX sets this. I think the depth value is this C500, that capital C argument.
5,000. I mean, that's
No,
for lots of great
500.
numbers. Yeah.
The
500.
default,
Okay.
well, the default that WSJTX uses is dash C500. I assume that's how deep it
All right.
tries.
That's probably it. But
Okay.
on a clean
Okay.
packet, you only need one decoder move per
That's
bit, not
okay.
500 of them.
So anyway, but 500 is what Joe Taylor chose, not me. Okay, that's
Understand.
what Joe Taylor and Steve Frankie chose, and that's what's built into the WSJTX. So they in Whisper Daemon, that's the default value in Whisper Daemon too. So most Whisper Daemon sites, most people leave that value at 500. They don't go in and fiddle with it. But yes, there are some who have tried even up to 5,000. And we've persuaded those people to back off. We do have a couple of people I think are at 1,000, but I don't think that's I don't think they're getting a lot of false decodes, but those people are not by any means the only source of false decodes. These false decodes come from all JTX, from these various scraper programs running on Red Pitaeus. So these false decodes are not unique to Whisper Daemon or WSJTX. They come from it seems to be inherent in the modulation technique.
Right. It's inherent in the short block size.
Yes, it's inherent. So the only
Harder you try to get everything out, the more often you're going to get garbage.
Yeah. Well, so Jim Lill and others are trying to establish how to filter out these bad decodes. Gwen's suggestion, and I think that this is one that HamSCI should maybe want to adopt if you're going to look at whisper data. If you're looking at things in aggregate, then it probably having maybe 1% or 2% of bad decodes may not make much difference to an analysis that's looking at the whole of the 6 million spots a day, and there's 60,000 of them are bad. Well, maybe that's something we just accept, and and it gets drowned out by the good data. But if you want to really filter it out, what Glenn does is goes to the Whisper Daemon database, where the spots include all of the information provided by WhisperD, by the nano decoder. And there, one of the fields indicates whether that spot was the result of an OSD decode. And if Gwen says, if it's an OSD decode, throw the spot away, it's worthless. So, um, so if anyone is using Whisper reports for radio science purposes, they ought to at least be aware of the corruption that's present in the database. And that that flag that I described is thrown away by the whispernet.org database. So you can't get that data from WhisperNet. You can only get it from Whisper Daemon, and the only reports in Whisper Daemon come from Whisper Daemon users. But that's about 40% of all the spots contributed every day. So if you look at the 6 to 7 million spots a day that are being reported, the about 4 million of them come from Whisper Daemon receive sites. So,
And
those
are these almost always packets that have the angle brackets around the call sign? I mean, that indicates it was filled in from a hash code, right?
that means that it couldn't find they couldn't find it in the hash table, but Whisper
Oh,
Daemon
wait,
throws
wait,
those.
no. If it couldn't find the hash table, it would just have dots there, I think. If it does find
Well,
that hash table, it'll put it inside angle brackets to indicate that it was found that way, correct?
yes, that's right. If you
Okay.
see a
And
a
are
call
those the
sign,
ones that are usually bogus?
good,
I mean,
good.
what I just said before,
Yeah.
somebody else implies that that's true, right?
Well, I would love you to. I don't know this. I haven't tracked their efforts, and I keep. I'm so busy with trying to get with your float
All
stuff
right, all right,
working.
all right.
I haven't gone into it.
Can I ask a kind of more fundamental question here?
Yeah.
And that again is the difference between FST4W and Whisper. I mean, okay, the FSK levels are shifts are close enough that it probably doesn't matter much. But we've got totally different FEC, total different framing format. The whole synchronization is different. So it seems to me that would just basically look like noise to a whisper decoder because there's no commonality in the underlying data.
Yeah,
now,
but Paul,
other than an FSK4, I mean the calls are everything is different. So how is it different?
Because the OSD decoder always comes up with a spot.
So my question is, how is that different than just random background noise?
It's
going into the whisper decoder.
Is
there some other? There's squelch function. Is there something that prevents whisper decoder from just decoding noise?
Well, that's what prevents them from just decoding noise is that the OSD decoder needs to find the call sign in the hash
But the
table.
call sign
So
is encoded totally differently. So why is FST4 any different than
remember,
noise?
there's the
That
hash
mention
table.
of the squelch actually sounds like plausible that, because there is a pre-processing that goes through and looks for probable signals and then throws a decoder on them. And that might be
Okay,
what's happening. Yes. Yeah,
that might
you
explain
call
it,
it a
but
squelch, but yeah, right.
okay, because I mean, but it's just gonna, the Whisper decoder is gonna be essentially decoding noise as far as the bits are concerned.
But
If it's
that noise will produce a spot. Okay, it will produce a
I guess
series of.
what I'm saying is FST4W is almost irrelevant. Any signal
Well,
that
you absolutely. You're
okay,
right. Yeah,
okay,
absolutely. It's not unique to 4W. I think that we're seeing more of them because we've turned on some 4W transmitters in the whisper band. And that was my theory at least, is that we've turned on these 4W your whisper sons. They're transmitting in the whisper band, and they show up as candidate signals to the
strong
whisper.
signals. Okay,
Okay.
rather
Okay,
than
and
background noise.
so then those candidates, 4W candidates, are handed to the Whisper D decoder, and the OSD part of it, generates a call sign from it always, as I understand it. At which point, if it's in the hash table, then it becomes a real spot.
Yeah,
So
okay, but so
my
it's
theory. Right.
but it's like loud noise. I mean, which I don't know
Yeah.
what we do about. I don't
Well,
other than, as Gwyn was suggesting, to say, we ignore the OSD decoded reports.
presumably, I assume that the Fano decoder itself can also produce a decoder, but it's much less likely to do so
Yeah.
because it aborts. Okay, and at some point, and so it's much less likely, as I understand it, the Fano stage of decoding is much less likely to produce a false decode. However, it's still possible to. And once it produces a false decode, okay, and puts it into the hash table file, then in subsequent passes, subsequent whisper cycles, the strings are
anything that
passed.
decodes to the same
Anything.
hash.
It goes and looks in the hash table, and if some piece of noise shows up with that same hash, then that becomes so you would expect to see if the hash table has a bad entry in it. Again, if Fano puts a bad entry, suddenly after that you see a whole bunch of them at the same call sign showing up because the OSD decoder detects it. So
I mean, this
I
could be the case. I mean, it seems to be that noise would, or FST, whatever you want to use as your stimulus, that would just as likely decode to what would otherwise be a valid hash for a signal, a station that was legitimately in your hash table. So,
yes.
The fact whether it's and those may be false reports that you're seeing, and you don't know about it because you look up that station. Oh yeah, there they are. But no, that decode wasn't actually from that station.
Yeah.
It was noise, but the
Okay.
hash resolved to the same as
Okay.
legitimate station.
Well, I think we've probably driven more people away from this meeting than that on this discussion. It can go on forever, okay? And there is a group, you participated with a bit with Jim Lill and Phil Barnard, who are trying to pursue this and come up with techniques to filter them out. But I haven't had enough time to actually engage with Phil and Jim.
Whisper short message length. I mean, as Phil mentioned, there's only so much you can do. I mean, let's say you had a message with, 2 bits, what are the odds that, one of the bits is wrong, but well, let's try the other polarity and, oh, hey, that's a legitimate message. You can only do so much.
Yeah. Well, anyway, I don't know that this isn't a real issue for the science community, and so that's why I'm sorry to
Well,
drag this. I
the
don't want to drag this
question
on.
is, what will be the effect of these
What
false
is the effect
reports
of these false
on the
decodes
science?
on? Yeah, on the science, really. And
It,
my guess is I'll bet Nathaniel's going to tell us we've been wasting the time talking about it. It's not really that important.
Well, it's hard to tell because it depends what type of analysis technique you use. If you do
Yeah.
what I'm doing, where you take like all the spots and you throw them all together and you just look for big patterns, it probably doesn't make a difference. If you're doing this sort of work that Gwyn is doing, where you're trying to like look at two individual spots and look for very, very minute details, then it becomes very important. So
Yeah.
yeah.
Nathaniel, I mean, as I understand it, in science, I mean, metadata is just as important as data, right?
Right, but what I'm saying is there are the problems that it sounds like that this is causing, it sounds like it's going to have more of an effect on some analysis techniques than on other
Yeah,
analysis
what I'm
techniques.
trying to say is metadata is important. In other words, you need to know how a particular piece of data was generated, and you also need to know what it knew. Unfortunately, the coders are throwing away stuff like that. It may give you a signal edge ratio, but it really needs to give you other information, like, how certain it is of the decoding result.
Yeah,
That's
ideally.
metadata, right?
Well,
Yeah.
that information is present in the extended database to the extent that the Whisper, there are all kinds of fields that are output by the decoder, by WhisperD.
Okay.
And
So
most of those
Nathaniel, if
fields
you
are,
wanted to, could use them
yeah.
to weight particular
Yes. Yeah.
observations.
Right.
Yeah.
Yeah.
There are fields that seem to indicate how deeply it searched before it got this.
Yeah.
There's whether it used the OSD decoder. They are the fields that are output are present in the all whisper.txt file that is maintained by the WhisperD decoder along with the hash table. So
But
the
I would
information
make
is
a
there.
plea for recording the raw data, rather than
That's
substitute
right.
the call sign into a hash field, just record the hash, right? Record the message as it was received. You can go back to previous messages and post-process
Well,
later if you want to. But
well,
I
well.
really argue, I mean, I see this in a number of contexts where people don't log the message that was received. They log some interpretation of it, and then somebody else misunderstands that interpretation.
Well, that's that the whisper the whisper decoder does not give us it gives us some insights, but I couldn't understand the meaning of metric, for example. They
Oh, I
label
know what a
these
metric
fields.
is. I can
Well, you
explain
know
what
what
a
it is. I don't. Well, good.
yeah.
We need as, but I think that I, not knowing any of this when I started this project, Whisper Demon, 5 years ago, I said, I want to record everything information that they give us. I'm going to put it into the database. And because I don't know what it's meaning, if it's meaningful or not
Actually,
for
the
science.
only way to be sure you're not throwing away information is to record the raw audio.
Yes, well,
Yeah.
yeah, we can't save those.
Right.
Yeah.
Well, we could. I mean, it's not that. It's only 200 or 300 hertz. It's actually not a lot more data than. I mean, we could do full day recordings of the
Yeah,
Whisper
you could
channel.
you could afford to tightly filter it. You got plenty of time. Delay's not a problem.
Yeah, well, it's we've got the C2 files, which are
Yeah, tightly
that
filtered.
are
Yeah.
the highly filtered. So this we could log the C2 files if somebody wanted to do something else with Whisper spots. That Whisper Demon can provide. We can archive this stuff. I just know people need
Yeah.
to tell us what they want.
I mean, I'll draw an analogy. Remember when people started digitizing documents? They would put them into page readers, and then they would put the scanned text into a file, and often it was corrupted. And it
Yeah,
was just terrible. I mean, OCR has gotten better, but the right thing to do, people found this out quickly, was you store the original image and you store the OCR version, right?
yeah,
So you can go
yeah.
back to the original image if you need to. And that's a principle we should use here. Always save the raw bits and all the metadata from the decoder. And if you want to provide some decoded information, fine, but always allow you to go back to the raw bits.
Well, that would exponentially multiplies the size of the databases.
Not really. Why should it? At
What's that?
most, it would double it.
Well, we're talking about a 10 hertz, 24-hour, 10 hertz wide data
No, no,
file
no.
for
I'm talking about whisper spot.
Yeah, I know. If you wanted to record whisper spots,
I
you
mean,
need to,
rather,
you need,
you've got the message you already have. All you have to do is add another 50 bits to it, which are the raw bits that were decoded. That's all you need. And then I can
well,
see,
that's it. That doesn't,
oh, this was
that,
a type whatever packet and it had this substituted in it and so forth.
I think that well, we can take this offline, but I
All
don't
right.
think, I'm not sure I understand it, but I
Because
did what I
I'm
did.
mentioning this because the hash codes seem to be a problem.
Well, I'm thinking about aging out the hash table files
Yes, they
because
should be. I mean, how long does a whisper transmitter go without transmitting its own call sign without hashing it? How long? How
oh,
long? I mean,
well, the way hashing works is that if a call sign is up to 6 characters in length, then you generate what's called a type 1 packet. And that
right.
type 1 packet contains the 6 digits of the call sign, up to 6 digits of the call sign, 4 character grid locator, and the power
Oh,
level. That's
right.
the
Well,
type
see, the
1.
problem
Okay.
is the grid square is not accurate enough. So you need to send another type of message.
Well,
Well,
really?
look, I mean, I'm in DM12, right? The center
I know.
DM12 is
Well,
Tijuana, so there's a
but if
lot of hams that look like they're in
But,
Tijuana
but
when
if
they're to the
okay,
left.
yeah, but if you go and look at your spots reports at whispernet.org, you'll see that I would guess that you're being reported with, if you have a whispernet, certainly if you have a whispernet.org account, they if they see that you are a registered whispernet.org user and a spot comes in from you, uh, with the grid locator that matches the one in your account, and your account has 6 character grid locator, they'll substitute the six grid
Yeah.
locator
See,
for
that's
that.
another example of interpreting data. I mean, sometimes you just want to see the message as it was received.
I I
Yeah.
agree. That's why I think that if you want to do good work with whisper
Yeah.
spots, you should go to
On
wait.
PSK Reporter, he doesn't seem to do that. So there's at
Yeah.
least one or two guys around
Oh.
here who appear to be in Tijuana when they're actually in the
Yeah.
US.
Yeah. By the way, that's another whole project. We now have a PSK reporter scraper into a ClickHouse database running on the Whisper Daemon 4
Because
server, which is
we're handing all our whisper spots to PSK Reporter now, like along with FT8 and FT4.
it has everything from PSK reporter.
Right.
Everything that I gather. I mean, I don't know.
Show up at
I
the
don't know.
SPSD.
And Andrew. Uh, I don't know Andrew's last name now. I've never talked with him. We just exchanged emails. He's the one, but he's a HamSCI member who did a lot of has done a major amount of work. I can't remember, but Gwen sat next to him at the last the HamSCI thing.
KC2G.
Yeah, I think that
Yeah,
KC4G or something.
KC2G, Andrew Rodland.
Yeah,
He only lives about an hour away from me.
Well, Andrew implemented a PSK reporter scraper, and because there's no good query tools for PSK reporter, and querying would really overwhelm the PSK reporter server. As a result, Andrew implemented a scraper, and with the encouragement and help of Philip Gladstone, is now scraping Philip's database into a Whisper Daemon server. So one of our tasks that we have to do is bring up this new server, and and um, and that will have all the PSK reporters, all of the Whisper, all of the FT4s and 8s everything is going to be recorded there. Extended spots, regular spots, and PSK reporter are all going to have you could be able to query them through our database. So That's it's a project that we have the hardware in place. We have a plan. I just have to finish this float recording and then we'll bring this online. So I think for those of you like you, Nathaniel, who would like to do big data analysis,
Mm-hmm.
there's 10 or 20 times the volume
Mm-hmm.
of data in PSK Reporter,
Right.
and then there is in Whisper.
Yeah. And we have that archived on the what do you call on the Madrigal database now too.
Mm.
That's what Bill
You're
Bill
you're
Engelke.
you're scraping PSK Reporter and
Phil Gladstone would give us the data files, and then Bill
ah
Engelke um aggregates them and then sends them to the MIT Haystack Madrigal database,
ah well
which
we have
which
a
doesn't which probably doesn't have the same performance that your ClickHouse database has, but it's a database that's well known to the space physics community.
yeah. Oh, good. Okay. Well, there'll be another. This is another source. I mean,
Yeah,
I've had almost no involvement with it other
yeah.
than when Andrew said he had implemented it, but he didn't have a place to run it. I said, well, put it on our new
I
Whisper Daemon servers.
yeah, I think that's really great.
And I was gonna encourage Phil Barnard to add query have his VK7JJ his Whisper.rocks be able to do queries on that once we get it up. So
I
there'll
think
be
that sounds really good.
so that's another one of my background projects that I haven't been able to catch up with.
Got
So
to run here, guys.
okay.
Talk to you soon.
I might say
Uh,
73 too. 73 as well. It's now like 11 p.m. here, so
Yeah, okay. Well, I'm
yeah.
sorry for the long detour into false decodes, but
Yeah.
uh,
No, I
it's
appreciate it. I'm glad you're
fascinating, and it
working
may
on
be
it.
important, probably important in one for a number of reasons.
well,
Okay,
it's
adios.
Okay, take care, Paul. It's
Yeah.
um
Thank you very much, Rob. I appreciate it.
okay, well, it's a bunch of stuff. I hate to, you know, bludgeon people with subjects that are not of interest to them. But the I think the important one is to get the float data into the Grape database so that we have. I mean, I look at those stripe charts and I see all those bursts of, I would expect to have a solid, a line, a single line that goes up and down. And and I don't know if that those bursts that we see the little flashes of, yellow vertical lines you see grouped together,
Mm.
whether those are the result of AGC mismatch or whether that's just some other phenomenon in there. But but I wanted to get the whole decode chain to be cleaned up, and it is now. So well, not yet,
That's
until like not uploading yet. So
well, thank you very much.
okay. So well, we've got to. I don't know if there's anybody. You're a good candidate. We could find somebody. There's other volunteers who could act as a second beta site. I think Glenn has recruited 5 people as his for initial beta site volunteers, and he's providing the equipment to them, everything except the mast. Glenn is providing it to them. So. So I don't know who the next 3 are. I know one of them. I think is one of my Whisper Demon guys up in Washington. But maybe we can get one up at Paul's when Paul goes back up and put up his site up there on the San Juan Islands. That would be a good site for high quality. It's already a high quality receive site, and this would add to it. So. Anyway, that's that's uh, that's all I can think of right now. So yeah, so if there's anybody else in the Ham circle who's really interested in being part of the early part of this beta set for the antennas, they could speak up. and I'll try to advance them. But it sounds like a visit to you in April or May or something. I'm
I
not
think that
sure.
that would be nice.
Okay, well that'd be a good time to uh, for me. I have pretty busy through March. I think I'll be pretty busy.
Yeah,
So
and we want you to come when the weather's better too.
I want to come when it's yeah.
Yeah, you don't want to come here before mid-April,
Yeah.
I think.
Yeah. Okay. Well, okay. Well, anything else that we wanted other people to talk about? Um, I overheard earlier, Clint, you mentioned Phil Barnard, VK7JJ, keeps throwing out these things about how much better the Kiwi is than the 888. And I think Phil just does not get it, that the 888 needs even more gain than the Kiwi. Um, so it would I'm kind of hoping in the background that Glenn in 6GN gets so
Well,
frustrated with the 888 that he goes off and designs
well,
a simple one.
I mean, adding the AGC probably puts Phil at a bit of a disadvantage because if you let if you let if you increase if you have too much gain on the 888 or Kiwi for that matter, and you're getting a lot of clip samples, you'll probably still perform better than you would if you were gain starved.
Well, I've encouraged Phil to put more gain in ahead of his because you look at his site and
Well,
his 888 reports his signal levels in there are minus 45, minus 50 on the input. So he needs another 20 dB of gain to get up into reasonable.
well, maybe not. Does he run a shelving filter?
He does have a shelving filter, yeah.
Okay, right. Okay, but yeah, um, in a gain starved situation, certainly without a shelving filter, the AGC is probably a bit of a liability.
Well, we haven't. The AGC is pretty much gone. We're back. We're down to
Oh
RF AGC only.
no. The RF AGC has to
Yeah,
be
the
there.
RF. Well, the RF AG has to be there. Yeah.
Right. If you want to avoid it. However, one thing that is generally true, especially with something like Whisper, is that if you allow maybe I don't know, it'd be interesting to do research on this, but I do know that you can actually overload pretty badly and not significantly impact Whisper reception. It might not be suitable for human listening, but if you're talking about, during the 2 minute cycle, maybe a second or two of just of trash, it probably won't materially affect the decode all that much. Whereas a human listener might find that totally objectionable. But in that case, what you're doing is you are um, reducing the probability that you'll gain starve a particular receiver. And I bring this up only because that I wouldn't be surprised if that's how his Kiwis are being run, is they're probably being clipped pretty badly. On the subject of gain starving, Phil, I was wondering, I don't know if you, I don't, it strikes me that if you're getting antenna noise if you're getting noise from your antenna port on your 888, that would vary lockstep with the AGC, that more or less. If it's maybe 6 dB above the noise floor of the receiver, would you generally agree?
Yeah, I mean, yeah, I've always believed that if you plug the antenna in and you hear noise,
Right. So
then you don't have a problem with the receiver noise. I mean, this is assuming that the receiver behaves properly with no antenna connected.
right.
I mean, to do it right, you should attach an attenuator. Attach dummy load, but
right. So one of the questions, of course, is that if you run the gain way up, you're going to start tickling your LSBs with the noise of the VGA. But I'm wondering if one of the stats you could add for receive channels would be does the noise floor change reflect the change in the front end gain? And if the answer is no, could you not automatically assume that that is a gain starved channel? See where I'm going?
In other words, look at my N0 calculation. I changed the front end
Right.
gain.
I mean, that if you stare at it and watch the two numbers at the same time, you could do that. But I'm just wondering, maybe, mull over in your mind, if you could have a gain deficit figure or figure of demerit in your receiver to indicate that, hey, this channel here, I mean, the noise floor isn't going up and down lockstep when I change the front end gain. You may want to look at this.
The thing is, I don't change the front end gain very often. By design, I try to avoid that.
Right. But I mean, you change it maybe up to once every 10, 20, 30 seconds if the conditions are going all over the map, right?
I do.
Right.
I mean, I deliberately made it slow.
Right. Yeah. And I have an AGC gain system that works kind of like yours on the Utah SDR, and it is purposely slow too. It's fairly quick to reduce the gain, but much less quick to increase the gain.
Well, you don't want to be too quick, right? I mean, it's just a static crash, then you're just knocking your gain down for no reason.
Right. Yeah. I have a threshold, and I also have a number of samples within a certain period that have to qualify, and I've fiddled with it over time.
Yeah, it's a trade-off. How much do you want to lose now versus how much do you want to lose later?
Right. Yeah, I have it fairly well set. I think it's like it's 768 kilosamples a second, which is what I run on a lot of the channels. It's like in like a tenth of a second, do you get more than like 2,000 clips or something like that? Then you might want to do something. If you don't do that, if you don't get that many clips, or not actually above a certain threshold, it actually goes on threshold, not clips. Then you say, okay, that's just normal Gaussian whatever crap it is, or it could be a static crash. Because one thing
you can model clipping as the addition of impulse noise, right?
Right.
You're adding a signal to whatever it really is to bring it back down to the rail limit. If you could model that, you could model how much noise power that is injecting. The problem is much of this impulse noise is not easily modeled.
Right. So the AGC is more or less driven entirely on thresholds, and I don't know that I don't think I even care what the clipping is. If it's above a threshold for so many samples over a window, just a window, then I take some action. If it isn't, and the requirements to increase the gain again are actually like 6 dB or 8 dB lower. But anyway, it's you can imagine how it is. I mean, ideally, it would be nice to have a piece of coax that was a couple of milliseconds of coax that was lossless, and then so you could look at the input to the damn thing and then decide what you're going to do before it gets.
Yeah.
I mean, you can practically speaking, you do that with a glass delay line, but we're not going to go through.
I got you. Yeah, I understand. It's a good thought experiment.
Right. But I'm interested. But it would be interesting though if you were to, as another receiver analysis point, to add like a figure of demerit to the receiver to indicate to the user perhaps that the noise floor isn't moving with the gain, and that could indicate gain starvation on a channel or a particular frequency or something like that over time.
That's an idea. I can do that. I mean, it'll take time to compute that.
Right. That's
average slowly.
Right. That's fine. And the other thing too that you got to convince people is that one observation is not suitable for setting your system, because of course you want to know, you not only you want to know the difference between day and night is, but you want to know between shitty conditions and gangbuster band openings. And the latter is the one that actually kind of defeats the facility of the shelving filter we have. But you know, I expected when I proposed the idea of the shelving filter years ago, I was expecting that to happen, but you got to use every tool you can come up with. So
Yeah. I think what you want is a correlator between the front end gain and end zero that just runs
Mhm.
and shows you, you know, what the correlation is somewhere between 1 and 0, right?
Right.
Zero means the noise level doesn't change at all with front end gain, and one means it changes in lockstep.
Right. That would be good. I mean, it'll never be one, but it should be close-ish to one. The other thing I was thinking about too, and I think you have all the facilities in it, is I was brainstorming ways if I want to add a VLF receiver. One of the things that I could, whether or not I could get sufficient signal noise ratio is another matter, but we already have things like 27 megahertz or whatever. Well, I mean, put it this way: it'd be trivial to have a VLF receiver that received from, say, essentially DC to you know a few kilohertz or maybe even 20 kilohertz that
Well, I
essentially
mean,
just disturbed a balanced modulator and produced a double sideband suppressed carrier signal, right? And
I'm confused. I mean, why not just use a sound card like Jonathan does?
well, here's the thing. Generally speaking, you want to put your VLF receiver way the hell over somewhere,
Yeah.
not near where you have power or anything like that.
All right.
But the idea would be, but so I mean, so the idea would be is if you had this remote receiver and you could transform or couple, you know,
Use fiber. Use That's what fiber is for.
or fiber, yeah. But the idea would be, well, fiber at, yeah, I know what you mean. But the idea would be is if you were to if you were to you know double sideband modulate up to like 10 kilohertz of VLF onto a carrier, I guess K9Q radio does have the ability to synchronously detect it if there's a carrier present and render a baseband. Would that be correct?
Yeah. I'm not sure why you're doing this, but
Well,
okay.
I mean, I'm just trying to think of ways to. I mean, first of all, leveraging an 888, you know, might be useful. You know,
No,
put it.
I mean, to me, I get the impression that, you know, part of the problem with some of these front ends like the 888 is that they're too wide, right? I mean, there's no antenna that can do justice to the whole frequency range of this thing. So maybe we shouldn't push it. Maybe we need, you know, dedicated receivers for each of our types of antennas. I mean,
Right,
I'm
right,
already doing that here. You know, I got multicast streams from a bunch of radios and antennas coming onto a common network, and I just pick the stream I want.
right. Yeah.
So, you know, build a dedicated, you can use KNIQ radio, it'll work fine to VLF. You just feed an input from a sound card,
Right. Well, I mean,
right?
I don't know
It'll
why
look
you
like a
wouldn't
direct
bother.
sample receiver with a, you know, 96 kilohertz, 92, what is it? 96 kilohertz sample rate or whatever they do now. That's what all it'll look like.
The problem is conveying the baseband from a electrically sterile environment, uncontaminated by the thing that is running the sound card.
A while ago, John Ackerman found optical remote USB interfaces, and I'd never heard how he did with that. His intent was to actually remote a RX 888.
Right. But one of the ways that I've seen done in the past has been to upconvert VLF as a block up to a higher frequency so you can magnetically couple it over a low capacitance transformer, then move it along the line, then shift it back down at the far end.
Yeah,
I mean, that's one of the ways to do it. I mean, you're essentially doing that with an optical link anyway. I mean, whether it's an analog opto link or whether or not you're spitting
yeah.
digitized.
Well, I mean, you can send analog signals over fiber. You know, radio telescopes that I know, like the ATA, currently have analog amplifiers only in the and the antennas, and they feed analog fiber that goes to the building with all the signal processing equipment.
Right.
So it is possible to send an analog signal directly over fiber.
Right. Yeah. Scott just sent something.
That's what I would, I mean, if we really want to do it and avoid digital electronics near the antenna, that's what I would do.
Right. Right. I mean, one of the obvious things too is that if you're doing it like you want, you do not uh, you do not send let's see, you probably want to have it self-powered, like a small solar panel with a
Yeah,
linear.
the other problem you have is, yeah, okay, what do you do about the power lines that,
Right,
yeah.
which kind of puts constraints on the power budget. Yeah,
Well, you could run AC out there, AC coupled galvanically isolated lines with transformers and shields and all that. I mean, we know how to shield an AC line if we want to.
right, right. Although,
Make it a twisted pair.
yeah, although I'm thinking of like in the case of like Utah SDR side, any wire we run out there has to be underground. Otherwise, the cattle get it. The cattle will get it.
Okay. Okay.
So that is almost that is almost a non-starter in the sense that if you want, you have to open a trench. So you have to be
Yeah.
really careful how to, or you send it wirelessly. I mean, the other option, of course, is that, I mean, maybe at some VHF or UHF frequency, you just send a wideband FM carrier that contains baseband, like the bent pipes of the SARSATs, for example. That's exactly what they did. With a high modulation
Okay.
effect, so that.
I mean, is your goal here to avoid any digital electronics at the antenna?
Well, no, the goal there is to have something extremely low powered that would be capable of reasonably being powered from a modest sized battery and solar panel, and
Oh, so
also
power that you're concerned about.
decoupling it from the power grid, because
Okay.
ideally you'd want to put it hell and gone from wherever your power is. I
It's
mean,
power that you're concerned about. Okay.
yeah, yeah, power and coupling into the power grid. I mean, practically speaking, what the people that go, you've done it. Steve McGreevy does it. I mean, he is probably finding places miles away from power lines. I mean, I'm not under any illusion that we'd be able to look at Schumann resonances, or well, maybe we could, but stuff we would find places where we would have minimal intrusion of the 120 hertz and harmonics.
Yeah.
But I mean, that would take being out in the middle of the desert practically. But I mean, doing it the best you can, not making the situation worse by bringing noise to it, for example.
Yeah. Well, I know we can filter DC pretty well. The problem is you can't really galvanically isolate DC very easily without some AC involved in a converter.
No. I mean, it would be practical to send extremely well filtered AC out there if like
Yeah.
like 12 volts from a
And yeah, the
transformer.
problem is if you put a solar panel out there already, you're talking about switching power converters.
Well, not necessarily. Well, not necessarily. I mean, I mean, if your power budget is not too bad, then you can lose 40%
Oh, okay.
in your
All
regular.
right. Yeah.
I mean, it's no big deal. I mean,
Yeah. Don't use a MPPT.
oh no, just no. I mean, if the thing's drawing 100 milliamps all the time to do whatever it does, then as long as you can, let's see, that would be what 2.4 amp hours, I guess. As long as you can store like 50 amp hours during a cloudy day, you should be fine. And that's
Yeah.
not all that big of a solar panel. I mean, it's a pretty good thing.
No, I was thinking about the charge controller and the noise that it would
Oh, yeah.
generate. You could use an old style charge controller that doesn't do MPPT, peak power tracking. It's less efficient, but it basically it's just a switch. Well, actually, some of them use PWM for some reason, but what all it
Yeah.
really is a switch that opens when the battery is full.
Well, I mean, if I were to do it, I would use a lead acid battery because lithium is out, of the question, obviously.
Why? Why?
You can't do anything with lithium below 0C.
Oh, okay. All right.
Yeah,
It gets cold there. I keep forgetting. All right.
yeah. I mean, it does get cold here. Lithium. No, there aren't any rechargeable lithium chemistries that are common that are usable below 0C.
Right. Many of them actually have heaters that they'll take the charging power to heat the
Correct.
battery instead of charging it until it reaches what, 0C or something.
Right. So what I would do is I just get a solar panel and maybe a PB 137, which is a 78 13.7. Such a thing does
Okay.
exist. It's a
Of course,
three-terminal
I mean,
regulator.
lead acid batteries aren't great below freezing, but I guess they work better than lithium. So, okay.
Yeah, as long as you don't get them below like 25% state of charge, they're not going
Right.
to
I don't know.
freeze.
I mean, yeah,
They're not going to freeze on you, at least not around here.
the fully charged acid mixture is a pretty good antifreeze. Yeah. Sulfuric acid is a pretty good antifreeze.
Right.
But yeah, still, I would definitely underrate them by
Oh
a
yeah,
lot.
yeah. I've used them for decades, I have a couple of notes here. The last thing I think we've determined too that the Nooks and the small PCs do seem to have a flaw that I had not foreseen.
Oh boy.
And what that is if you're talking about a desktop PC, they have some capacitors in there like 220 microfarads at 200 volts in series. That's a fair number of joules, and if the power goes out briefly, that thing can ride through. It
That's
seems
right.
we're discovering in the northern Utah that a laptop power supply is absolutely incapable of that.
The back
So what
capacitors
happens?
aren't big enough.
Yes, there's not enough storage in a laptop supply, which is what runs NUCs. So what
Yeah.
we're
Well,
finding is in the 150, 200 milliseconds it takes for the UPS to go clunk, we are dropping the NUC. And not only that, sometimes it does not recover unless it wedges it. It's too fit.
well, this is what UPSs are for.
Well, the UPS is not fast enough. This is a
Really?
reasonably normal UPS. If you have a UPS, typically if you see like a UPS.
Actually, I know. I mean, standby power supply. A UPS would solve the problem, but that's not what most people use.
Right,
It's a
right. They're
standby
using
power supply with a relay.
yeah, they're using something that the power goes bad. There's a clunk, and if you have an incandescent
Yeah.
light, you can notice it go flicker.
Yeah,
Just
technically that's an SPS, not a UPS. Yeah, but
correct.
that's
I
what
mean,
it
yeah,
meant. Yeah. So you're
right.
saying that even that is too slow for it, huh?
It seems that it seems likely that under conditions like for example, supposing we get a power bump, and we get a crap ton of power bumps out there at the SDR side. If it's really busy and it's fully loaded, for whatever, the worst case seems to be when it's doing all the whisper processing and it's pulling the like 60, 70 watts. That thing cannot hold it at all.
Not
So
enough for the relay to pull in,
apparently not.
inverter to start. Okay.
Yeah, yeah. I mean, so
Well, now
so
you need a DC UPS. You
well,
need a
what
20
we're
volt
going to do is
DC UPS.
it turns out from Mauser Key you can actually buy some like 3 farad capacitors that are rated for 22 volts.
Okay.
And
Might work.
yeah,
How much? What would that do? I mean, remember, you can't pull the power, or you can't pull energy out of a capacitor without letting its voltage drop. So you have to.
correct.
How low
Right.
can you go before the power supply and the computer stops working?
It would seem that the 19-volt input NUCs handle down to about 15 volts ish.
Okay, not 12, huh? That's too bad.
Well, it's a 19-volt. It's a nominally 19-volt device.
Yeah, but I mean, it goes into switchers. I mean, those switchers, can often have a wide range, but it might
Right,
be
but
too much to power them off at 12 volts.
right. But we only need to do this for 500 milliseconds would be more than adequate in this particular
Okay.
case.
All right. So how much energy can you store in a 3 farad capacitor when it drops from 19 to 15 volts?
Well, 3 farads, if you think of the definition of a farad, 3 farads would be 3 amps to drop 1 volt.
Right.
So there you go. And it's
Oh yeah, I
probably,
don't even think, don't think of energy. It just complicates it. Okay, so
it's
yeah, it
probably
could
pulling
deliver
about probably,
it could deliver 3 amps for about 4 seconds then. Okay.
yeah, probably. And yeah, and I haven't tried them yet, but you can also buy ideal diode modules that have like 50 millivolts drop, and I'm going to see if those are adequate. If not, I'll just have to use the Schottky and live with half a volt drop. But
What's the ideal diode for?
it would, well, you cannot connect a capacitor like this across a
Oh,
power supply.
of course. Okay, yeah, the power supply will drag it back. Okay,
Yeah,
yeah.
I mean, you'll probably either blow up the power supply or just instantly trip it out with because it's a
I'm
short.
not sure why, but yeah, okay, it's
Yeah,
better. It's safer to use
yeah.
a.
I mean, essentially, you're shorting out the power supply for minutes, or
Well, I've often backfed power supplies with batteries while charging, and
right,
it doesn't seem to cause any harm. But
right. But capacitor like this is a dead short when you connect it.
you're talking about inrush current.
Oh yes, yes.
I thought you were talking about what happens. I thought you were talking about the capacitor
Oh
discharging
no,
back.
no. I built this here. This has.
Oh, okay. It's a circuit I built many times. Oh, okay, I know what. Wow.
Yeah, I mean,
Okay.
with this here, I can actually run a 100-watt sideband radio off D batteries with it.
Yeah, I
If I,
remember electronics class in high school saying the teacher saying we would never see a 1 farad capacitor. I remember that.
yeah, this has.
We probably all sold that. Yeah.
I think this has 350 farad capacitors in series,
Yeah.
but there's a whole circuit on this. When you flip this on, it dumps about 3 amps, current limited into the capacitor bank. Otherwise it would just. I mean, this could start a car.
So you want to build basically the solid state equivalent of the relay surge limiter that I built many times back in my high school days. The relay and the power resistor.
Oh yeah. That's well. In this case, it doesn't need to happen very quickly. So all it's going to be is like a 100 ohm resistor with a diode across it, essentially. Because I don't care if this thing takes an hour to charge.
I see.
Yeah, I mean, yeah, it really doesn't matter. I mean, it's 100 ohm 5 watt resistor would. It might take an hour or two to.
Assuming the load isn't so high, it'll never let it reach the. No, wait a minute. No, that's right. Okay.
I mean, it'll never, of course, it'll never get to fully charged voltage, but it'll get close enough. It's well, like that joke about engineers. It's like,
Oh, be close enough. Yeah.
yeah.
That joke,
Step
yeah.
one step, have your distance toward the toward the
Right.
girls.
Right.
Yeah.
Right.
Eventually, get close enough for all practical purposes.
Well, it's we engineers do. We estimate.
Right.
Most of the skill is knowing when to estimate and how much.
Right. So, the capacitor and whatever the ideal diode modules arrive tomorrow, and I'll let you know how that goes. I've never used ideal diode modules before, but I don't know for sure that they'll work in this thing. But there's some sort of ASIC on them that turns on a FET. So, and I don't know
I'm
exactly.
sorry. Wait a minute. It's an ideal diode. How are you going to wire this with the resistor? How does this work?
Well, you just put it. I mean, you put. Not counting an ideal diode, you just put a diode reverse biased across the resistor so that when it's charging the capacitor, of course, you cannot short out the power supply. But when the capacitor is being discharged, the diode conducts, and the ideal diode would fit the place of the normal diode.
I'm still confused. I know it must be simple, but.
Well, so the capacitor is always lower voltage than the power supply when it's running, right?
Okay.
Right. So you have a reverse bias diode in the charge direction for feeding the capacitor. But if the capacitor is higher voltage than the power supply, as in the power failure, the diode will conduct and bypass.
And do what?
What?
Oh, well, where do you put this? Between the power supply and the capacitor? The capacitor and the.
Well, you have the capacitor on the bottom and you have the diode and the resistor on top. And you have that combination of capacitor and the diode resistor in parallel with your output of your power supply.
Oh, I see. I see.
Yeah,
Okay.
there you go.
Right. It's in line with the capacitor. Yeah.
Right.
Charges slowly, discharges rapidly. Okay, got it.
Right. Charge it slowly, discharge it rapidly through the diode.
Okay, I was thinking it was somewhere else. I couldn't figure out how it would work.
Oh no!
Okay.
In fact, what I'm going to do is I'm just going to put I mean, the B links have 2.5, 5.5 millimeter coaxial adapt connectors on them, and I'll just put this in line with it. Just it'll have a female out socket and a short
Yeah.
cable, so it just plugs in series between right at the PC.
Let us know how it works. I mean, this could be a useful device for a lot of people.
Right. Well, I thought about this for a long time because I have a Tesla Powerwall here, and I know other people have similar things. And one thing everybody has discovered is if you do a grid failure, these whole house UPS battery dugats can take anywhere from 50 milliseconds to 700 milliseconds to switch over.
Yeah.
Which means if it takes anywhere near the ladder, every computer in your house reboots when the power goes out.
Yeah.
Which means you
Well, it's not
still need
the
to have
batteries are not the problem. It's the inverter and the logic and the relay and all that stuff.
and also being able to detect what a power failure is.
Right.
So what that leaves people with these things is they still need UPSs on all their computers, but the UPSs really only need to last a second.
A second, yeah.
So or a couple seconds. So what that probably means is that at some point when I get given batteries, lead acid batteries, they last 4 or 5 years before the thing starts beeping because they're bad. At some point, I'm going to just load one of these up with some super caps because if the UPS only runs for 5 seconds,
Yeah.
Yes.
Why spend money on batteries? Yeah.
Right.
For caps to last longer.
Yeah, it's either the power wall is either going to kick in within less than a second, or it's not going to kick in at all. So
yeah,
that's the deal. But yeah, that's one thing that seems to be about.
This happens to everybody. I don't know if you're old enough to remember Apollo 12 and the problems they had during launch when it got hit by lightning.
Oh yeah, and
the cells dropped offline.
Yes.
And what happened there was they had batteries on the bus, but these are silver zinc batteries. It turns out they're an unusual chemistry. When you throw a load on them, the voltage drops and then recovers very rapidly. It has to do, I guess, with the reactants moving within the battery.
I think it's called a coup de foie or something like that. Lead acid batteries do this too.
Oh, you put a load on them and there's a sudden drop and then it recovers?
Yes, and
like within milliseconds. Within milliseconds.
Well, lead acids are like I took in a previous life. I took care of a 300 kVA UPS. It had 2 parallel banks of 40 12-volt batteries in series, and when it was loaded fairly heavily, like 120 kilowatts or more like that, the normal voltage is like 540 volts. You could, I installed a battery monitoring system that would look at every individual battery very closely, with just maybe 50 millisecond sampling. And so after a power interruption, I could replay what individual batteries did to see it. And that's one way that I could catch a battery that was failing long before it actually was a problem. But you would see that coup de foie, it would just go boink and just slowly come back up. And a lot of that is the fact that chemical reactions increase in speed when things get hot. And of course, you're pulling 200 amps off this 12-volt, 100 amp hour battery. Things are going to get toasty inside pretty quickly.
Yeah. Something's going on. There's a passivation layer on one of the electrodes that has to be taken or something, when you put it. Yeah. But that happened on Apollo 12 and they didn't understand what happened. That's why the electronics got glitched. And that famous call the ground controller made to switch over SCE to aux, all that really was turning the power off and on again. That's all it did. I looked at the diagrams. So while, every IT guy has been saying this to people, dozens of times a day, one guy became famous for saying it.
Yeah, so it's the phenomenon is it's however you pronounce FOUET in French. coup de
I've
foi.
heard, yeah, I think I've heard that when I was really into batteries. I remember seeing that term. I'd
Right,
forgotten it
right.
though.
That's and
FWET.
of course there's the Pukert number as well. That's the other big thing. The Pukert
What?
the Pukert. So the
Oh,
Pukert
Pukert.
number,
Oh, yeah. Oh, that has to do with the life versus discharge life versus load.
correct? Yeah, and like lithium batteries are closer to ideal than lead acids were. Yeah,
What was that French word again?
FOUET. Coup coup de F COUPDEFOUET.
Oh, fluid means whip. Okay.
Yeah, that makes sense. Yeah. It I don't know how that's pronounced. I'm guessing it's like all French, fancy French words.
There we go.
It's just
AI says there are multiple matches for it, including a French phrase, a phenomenon lead acid batteries, a syndrome, a magazine, an energy gel, and a chocolate bar.
yeah,
Oh God.
yeah. I have no idea how it's pronounced, but yeah. When you're talking about a system, 300 kVA system that's pulling 200 amps from a 100 amp hour
Yeah.
battery, everything has to be going just right. Otherwise, it falls on its face.
Yeah. It
Uh,
means a stroke of a whip,
yes, that makes
what it
perfect
means in
sense.
English. Yeah.
And 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 uh, and a really good battery, that was doing well had a rather pronounced one of those. A battery that was kind of dying really didn't do that. One that
I guess
had higher
that
internal
would be a good
resistance.
way. Yeah.
Yeah, I mean that was one of the. I was in charge of the system for like 15 years, and there's and I could tell a battery was on its way out like 3 or 4 months before it. Usually 3 or 4 months before it actually happened. Although I
Yeah.
did get surprised once in a while, a battery that looked perfectly good would just burn open, during a power failure.
Here's a
That
paper out of Poland, coup de fouet effect in estimating battery state of health. So you're
there
not
you
the
go.
only one to have the idea.
Right. Yeah, I probably read it somewhere. Yeah.
Oh, it says observable in their first minutes, huh? Followed by a transient recovery.
Yeah. I mean,
Oh,
it's a very pronounced whoop-de-doo, and it just drops down and on a 540 volt DC system, that's quite a few volts. I mean, if you just watch
yeah,
the DC input of the UPS, you can just
yeah.
watch it climb back up. Then it's
Apparently, with
yeah.
with silver zinc batteries, though, this is a very rapid phenomenon. It lasts only milliseconds.
Oh, okay.
So the voltage on the bus, when the fuel cells tripped off and the load was thrown very rapidly onto the batteries, voltage dropped way down and then recovered within milliseconds, too fast for them to notice.
Uh,
They couldn't understand why things weren't working with adequate bus voltage, but that's the reason why.
the other
Uh,
thing, these days you just blame it on the switching supply, right?
exactly,
Yeah.
exactly.
Although Apollo was full of switching supplies.
Yeah, they had them. That's right.
I mean,
Had
they were no
inverters.
dummy. They knew they they
They
knew.
actually used three-phase 115 volts, 400 hertz quite a bit.
I could imagine that. Yeah, Curious Mark did some teardowns of the Apollo computers, and
Yes.
they were full of like 85% efficiency switching supplies,
Yeah.
and which it strikes me as being duh. Of course you would.
Yeah. I mean, today I do it the way they do it in the ISS. The power supply is at 125 volts DC or something like that. I mean, that is the right way
Right.
today.
Yeah. Just
Although talk to Kerry Banky about the rules about connecting to that. Man, the number of times he's been called to Houston to requalify Eris equipment because they tightened the rules once again on stuff that could be plugged into the ISS power supply.
uh yeah.
Apparently, the stuff has to be able to withstand these huge spikes. So I noticed when I went to his garage, he had one of these big Class D or E audio amplifiers. I asked him what it was for, and he said he was using it to qualify the power supply by applying these huge AC waveforms and spikes to the power supply input.
Okay. Yeah. I mean, they get low. I mean, it's like an alternator dump, I guess. But but in steroids, I
Something
guess.
like that. Yeah. Apparently, they actually had some failures on the ISS caused by some bad equipment that led to all these rules.
Well, I mean, capacitors blowing up and stinking up the places, and certainly a no-go up
Well,
there.
no capacitors here. That's a design rule. No electrolytic capacitors.
Okay, that makes
So
sense.
it's hard to build an AC power supply without electrolytic capacitors, but you can do it with DC.
Right. But I've been stung a number of times by failing monolithic ceramic capacitors. Those those will burn a board down in a big ass hurry.
They rarely had to fail. I mean, it's electrolytics that usually blow up on you. I had one blow up my face once.
Oh yeah, I've had plenty of them go bad.
In a laptop power supply. I was, we were taking down Brian Cantor's repeater on a mountaintop. It had been stuck on for months. It turned out that the computer controlling it had failed, had pulled the PTT line down. And when I disconnected from the repeater finally went off the air. The power supply, we could fry an egg on it. 900 megahertz repeater. Somebody reported it was still in the air. And then I figured out that the reason the computer failed is because the power supply it had shorted its own internal converter had shorted her external power supply. I pulled that out, plugged it back in a couple of times, and the capacitor inside the power brick blew up.
Oh
It
yeah.
was not the main capacitor. It was one of the ones on the output, 12-volt output.
Yeah, the those Samlex, the ham type shack switching power supplies are famous / infamous for blowing up their output capacitors.
Yeah.
Lots of people have. It even happened to me one time. You turn it on and suddenly steam comes out of the whole thing.
Why would that be? I mean, at least they don't have as much energy in them as the high voltage capacitor.
I'm not sure. I mean, it probably all depends. I mean,
Are they underrated?
Well, I think it. You look at the brand, and they're brands you'd never heard of. I've never had a problem with the higher grade Nishikon or Panasonic. What? I mean, those unless you do something stupid. I mean, those last longer than you care. Probably.
Yeah. Well, okay. So they're just bad capacitors. At least, hopefully, they're not using bad capacitors for the high voltage cap on the.
They're they're under a bit less stress, of course. It's the amps ripple that. I mean, that's the critical rating, and of course, at 300 volts, your ripple current's going to be a tiny fraction, which is also why a lot.
Oh, I see. Yeah. I forgot. That's right. There's a lot of AC flowing through these things.
Oh, well, yeah. Well, it's ripple current at, 40 kilohertz or something.
Yeah, it's a lot of AC. Yeah, and that's a lot of heating.
Right. Then that's what murders them. In fact, I've noticed that often in switching power supplies, the high voltage capacitors are not low ESR, and they're not 105C either, and they usually last okay. But
is there any inductive? You can put an inductor in there. It probably can't do enough to really make a difference at low voltage like that high current.
That's a good point.
I mean, of course, there's obviously an inductor on the switching supply. There has to be for it to work, but
right.
But I don't know about on the output side whether it's possible to.
So I mean, typically what they do, the good ones do, is they'll have a full wave rectifier, usually a center tap output transformer. Then they'll have some filtering. Then they'll have a big beefy inductor that has all of like 2 microhenries or 4 microhenries. Yeah. Then they have more capacitors, and of course that just scrapes off.
So the inductor should lower the AC current in the capacitors a little bit, I guess.
In fact, it does. Yeah, if you probe on either side of the scope, you see a noticeable difference. And but you think about 4 microhenries at 40 kilohertz. That's not a very high Z value.
Yeah.
But it does make a big difference. But I think they're not necessarily what they're going for is they're attenuating harmonics that might raise havoc with the device, like the radio that's attached to it. Of course, that's the whole point. I mean, it probably very little. And you know, if you look at a typical, you know, ham radio bench power supply switcher type, you'll see 50 to 200 millivolts of ripple at, you know, the switching frequency on the output.
You know what
And
they need is a three-phase inverter or three-phase
well, like they do on,
converter.
yeah, 3, 6, 8, 10 phase, like they do on PC motherboards these days. I mean, they'll
Oh,
have,
they do?
oh yeah, they have a lot more than 3 phases on some of them, so they can, you as you point out, the 3 phase reduces your ripple voltage tremendously. If you throw more phases at it, even you're even better off.
So these are independent inverters, all producing phase locked three-phase power, huh? That
Um,
then gets rectified into a common bus.
well, like on a PC power supply, like the core CPU voltage is like a volt at 80 amps.
Right.
Yeah, and you
Oh,
can think,
you're talking about that one, the one that produces the 1 volt for the CPU. Yeah,
yeah,
that's on the board. Yeah.
yeah, those are much more than 3 phases. So you can have a
Oh,
small amount of capacitance, because there's no way in hell you'll get your ESR low enough at 80 amps at a volt to make things happy. You just got to start out with a crap ton of phases and lower,
oh,
offset.
essentially, there's a bunch of converters in parallel that are all locked in phase and
Right,
frequency.
right. Yeah, there's some wonderful chip that does it all for you with like outputs to 12 or FETs or whatever, do synchronous rectifiers and everything
Yeah.
else.
If you really want to see this stuff, go to one of these converter stations for a high voltage DC link.
Oh,
Those are impressive.
I've only seen pictures.
I've seen pictures, yeah, but in the yard outside, they've got these resonant networks for each of the harmonics that aren't automatically taken out by the multi-polyphase
Right.
stuff. And the inductor is the size of a switchyard transformer. That's an inductor, and then there's a
Yes.
capacitor that serves with it to take out the however many hertz. Then there's another one that's smaller that takes out the next harmonic.
Yeah,
That's
I've seen pictures of that. A former boss of mine years ago did some work at the Sylmar plant after the 72 earthquake down there.
that's the one. Yeah, that's one of them.
Yeah,
Yeah.
yeah, and he had some pictures, and there was mercury and porcelain everywhere. He said he worked for GE at the time, and
Oh, they use probably mercury vapor tubes
uh,
in those
synchronous synchronous
pyrotrons.
gyrotrons
Yeah.
to rectify it. At that after that, I think at that point they switched to SCRs or something.
SCRs, and then eventually switched to MOSFETs.
Yeah, they're using IGBTs these days.
Or IGBTs, excuse me. Yeah.
Yeah,
That actually made a big difference. The switch from SCRs to IGBTs is actually a major improvement in high voltage DC
oh yeah,
because you can turn, right? SCR can't turn, it has to be line commutated.
yes,
And what that means is you can't practically have taps on the line. That's why the DC lines run from one point to another point with nothing in between
yes, yeah,
because they use the line commutating inverters, but the newer ones will allow multi-drop lines, which is a big deal.
right. Yeah, out here in Utah, there's the IPP plant out at Delta goes down to Southern California. I don't know if
It goes to LA. Yeah, I've seen that. That's the one you see when you drive 15 to Las Vegas.
yeah, I guess you do see it. Yeah, and
Yeah, it
I
crosses the
have
line.
last time I drove under it, it apparently wasn't energized, but I have driven under it and watched the compass do this as just hold a magnetic compass and drive under it slowly, and you can watch it.
Yeah,
And
right.
and then on the AM radio, you hear a hiss rather than a buzz.
Yeah.
But the last time I was out
Got to
there,
be some
it wasn't
harmonics
that good.
coming out. But
I've never heard it. It just was a hiss.
it's that clear. It's that clean, huh? Wow.
Yeah. Well, ideally I would have recorded it and run it through something. But I switched the radio to AM and heard a hiss. Didn't hear
These
an
DC
audio.
lines have an interesting degraded mode. I don't know how often they use it, where they can take one conductor down and keep the other one going
Oh yes.
and turn by earth. And
Right.
these massive ground, ground connections to allow them to do this.
Yeah. Some of the DC lines in Europe use earth return.
Yeah, not routinely. You don't want to do it routinely. Just just there in case one of the conductors fails. And you can run the line at like 40% rating or something. You can't run it at half because of the ground connection.
Right. Yeah.
Very elaborate earth grounds.
Oh yeah. Yeah. There's some
carrying
Scandinavian ones
thousands
that primarily rely on earth grounds. Apparently, I mean they're undersea ones. I guess
Yeah.
they did the
Well,
numbers.
Earth return is common in Australia. I mean, I've been talking to
yeah.
VK5QI. He's got some serious power line noise problems down there. And I found when I used the QESDR, I could see what he meant. But Earth return is apparently common for primary circuits in Australia, which is pretty surprising.
A friend of mine, WA7ARK, his wife grew up on a farm in southern Alberta. The first time he went there to meet the family, of course, he flew in on his airplane and following the road and realized that, wait, there's only one wire here. And it's one of the first things he did, being a nerd he is, he got out and looked at the power transformer and realized that there's one wire overhead and like 4 or 5 ground rods around.
Yeah.
And
that is, yeah.
And it was like 6-8 miles that line ran.
And you wonder about, if those grounds fail, I mean, people can get electrocuted by being there.
Well, that's also one of the reasons why Canada was a bit vulnerable in the 1989 solar event, where you got
yeah.
I mean, they saturated cores with DC current flowing. I mean, and tripped off monitoring, and everything like that.
Well, because of telluric currents, yeah.
Yes,
wow.
Yes. And since
I was
then,
thinking about the big long haul lines. I hadn't thought about earth return distribution circuits.
Yeah, and they were common in the U.S., but I think by the 70s they got rid of most of them, at least in the lower 48.
Yeah. Well, you'll still have large DC currents and power lines during a geomagnetic event.
Yeah.
I assume they just can open breakers if necessary to protect transformers.
Right. Yeah. Yeah. I don't know how they do it. Yeah. But yeah, all sorts of fun, cool stuff. I mean, but
yeah, power has always been one of my side interests,
many back probably in the early, one of my first jobs and into the mid 90s, I worked for a company that did SCADA systems, mostly for power. So that's where I learned a lot of stuff. Like I learned how, talking to power line engineers, how trivial it would be to simply black out an entire state, for example.
Oh, yeah.
It's super easy and not get caught.
Yeah. When I go for a walk in my neighborhood, I'm always amazed. I look up at the power lines that I know are carrying all the power to this subdivision. I look at how thin they are.
Mm-hmm.
And all this power, the whole neighborhood goes to this one power line. Because the voltage is so high.
So I don't know if you know about this, but in 1981, 82, there's a statewide power failure here in Utah. And in fact, I worked with the guy that was the chief investigator. I heard it from him.
Statewide. Wow.
Statewide. And so what had happened was that if you've ever been to Salt Lake, it used to be that the state prison was near the southern end of the valley. And the 345 kV and 225 kV power lines, there's a corridor where, a bunch of big towers and wood pole ones. They ran right through the prison yard. And so the prisoners are burning trash right below the power line in the iodide.
January 8th, 1981. I found it.
There you go. And at 345 kV, once you ionize that, it will not clear on its own until, it doesn't clear through zero cycle. But then again, you have 3-phase too, so nothing's at zero with respect to, totally at zero. And that took the state out, and they had to do black starts on the power plants.
Wow.
Yeah.
I see it here. Yeah. Prisoners on a work assignment burning trash and debris at the Utah State Prison in Draper accidentally caused a major power failure when something they were burning exploded, causing a fireball that shorted out transmission lines above them.
Mm-hmm.
1.5 million people lost power in almost all of Utah, as well as parts of southeastern Idaho and southwestern Wyoming.
Yes. Yeah. So, yeah, I mean, yeah, they physically had to get everybody on hand, and they had to go out to substations, open distribution lines, and feed like hydropower, which could run on its own, to black start the coal plants. Because, I mean, a coal plant, you need like 30, 50 megawatts just to turn on a coal plant. And
Yeah.
the coal plants did essentially a scram, you know, of their steam.
Yeah, I know what Black Start is and why it's so difficult.
Oh yeah, yeah. In fact, I was driving past one of the power plants, and I noticed on the roof, it was the Hunter Emery plant down by Orangeville in Utah. I was ways back from it. It's a big ass plant, like gigawatts class ish. And I noticed that on the roof there were dozens and dozens of pipes of various lengths, with all cut at angles. And I was wondering, what the hell is that? And one of the hams, he was a consultant for the power company, and he said, "Well, that's if they have to dump their steam, and if you have a straight cut on a pipe, it can tweet like a whistle. Can you imagine how loud
Yeah.
a 2 or 3 billion watt whistle would be?" But
Yes.
he said that he'd been at the plant when they had to dump it, like they had to dump a generator because of a fault. And he said it sounds like the gates of hell are opening up, because just an absolute defining
I
roar
can
of
imagine.
steam going off. So you can imagine what all these plants must have sounded like, you know, across the state of Utah, when the 345 kV volt line faulted out, popped the breakers, and then suddenly dumped the load on all these power plants. But it took more than a day for all the stuff to come back online,
Well,
because
all
you had to
through
go around
power law.
isolating it, bring it up, and start adding load gradually. Oh yeah, yeah. I was in school at the time, and we got sent home.
50-gallon drums containing a flammable liquid on the fire.
Yep,
Jeez.
yep. It would have been
I know.
interesting to have been under the guy that was later my boss. He was at his work, and then he noticed the lights go dim, you know, at his office. He looked out the window, and he was, you know, like, he was by the Salt Lake International Airport, and the lines run near there, and those lines are actually galloping from the current.
Yeah.
I mean, and it wasn't windy. You know, then of course it all went out. So now, on this sort of kick, one of the weirdest things I saw, and never saw an explanation for it, was I lived in Flagstaff for a while. You know, I went to NAU down there, and I was on 80 meters one night on a Friday night with from friends, you know, Salt Lake and Idaho and Oregon and all that. And I was noticing, eventually I noticed that the incandescent lights in my room are going brighter and dimmer. So I plug a voltmeter in, and it's doing this. And after about 5 minutes of that, I mentioned it on the air, and the guy here in Salt Lake said, "Yeah, it's happening up here too. I'm watching the plate voltage on my meter go up and down 300 or 400 volts." And it got faster and faster and faster, then it suddenly stopped. And what that was, somebody motored a big ass generator. And it probably did not end well. So yeah.
Oh, Scott, I posted a link to somebody, a ham who built a optical link. So the
Yeah, I
chat
saw
screen
that. Yeah.
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 Always
I
doing via
wonder how linear it is. Yeah, I've done a fair bit of optical stuff.
Well, I mean, you know, it is used. I mean, there's precedent, and radio astronomy uses it.
Right. Yeah. Yeah. It's a less utility for, because, you know, of course, anything out there, the WebSDR said, either has to go high enough that the cows can't, or farm trucks can't get it, or buried so the cows can't trip over it. Cattle can't trip over it, because it is grazing land we're on. And
So can I turn the conversation back to
or
Yeah,
radio?
what's up?
Um,
I'm
I,
just I'm working on liquid DSP, trying to see what I can use out of it.
Good. Well, I posted up. I'm still a little bit uncertain about the PCM record wave files, and I put up
Okay.
an example that if I look at the start times of them in
The start
detail.
times or whatever the clock says, you can
Yes.
ignore it.
Okay, but okay. So then
They're mainly useful for sorting. You know,
so
if you want
why does the last write time, okay, if it started at second 0, okay, why does it stop writing at second 59.90? How could
because, okay, I mean, you can think of any number of reasons. You're comparing a sample count, which is coming from packets, which have a little jitter. I mean, comparing to a time of day clock that's being steered by an NTP algorithm that's following a very noisy, upstream source. So I'm not surprised at all. I mean, I noticed this too, and I thought nothing of it. The important thing is that if you just cat a bunch of these files, they'll sort automatically in their proper order.
it does seem to work properly. I mean, it was a little disconcerting that the file times, there are file write
There are
times
scheduling
that are
delays, there are disk seek delays, there are all sorts of reasons for that.
okay, but
I would have been very surprised if they had been all exactly correct.
Okay. Well, the start times are sometimes second 59, and other times they're second
Yeah,
01. And
sure.
okay. Well, I just
I
want to
did
be
that
sure that
because, well, if there ever is a problem in that the sample clock starts to diverge, you'll see it because those times will start to go way off.
yeah.
But as long
Okay.
as
Well,
they just
that's
jitter
okay.
around 0, there's no problem.
Okay. So do we know that there are exactly the 720,000 samples in each of these files?
Do it. Look at the file.
Well, I thought the way
Track the raw data,
file,
pipe it to WC, it'll tell you. Huh?
It does, but the way you write the files is you write you use the RTP sequence number, whatever it is, the timestamp to
Timestamp.
figure out where the offset of where to write the
Sure.
And that means that if say something gets missed or there's an out of order, that you could end up not just leaving a part of the file with zeros. So the file would
That's
be the right
correct.
size. The file would
The
be the right
plan.
size. The right
That's the
file would be the
plan.
right size. So what happens when when a RTP packet comes in and there's no file for it to go into? That file's already been flushed out.
It's dropped.
Okay, that's fine.
It's easy to drop a packet.
Yeah, well, that's good. That's okay. I just wanted to check on
I
that.
mean, much of the restructuring I just did in the monitor program is how Opus handles packet drops, which is very different. PCM, I mean, there's nothing you can do. It just plays silence during that time.
Yeah.
Opus codec has a really interesting packet loss concealment feature where if you give it just a null packet in place of a regular one, it will try to fill the gap, and it does it remarkably well. I use it now for like listening to repeaters and stuff, and the quality is definitely better than it was now that I'm using that because I'm listening over Wi-Fi, and Wi-Fi has a lot of jitter and resequencing. Sometimes packets get dropped they come in too late. So I'm really pleased by this.
Oh, good. Okay. Well, that's fine. I just wanted to check with you. It seems to work perfectly. I mean, once I figured out that I had to just
of course it works perfectly. Of course it works perfectly. I wrote it.
It didn't work perfectly at first, but but now it does. It's no, it's really good. It's so incredibly efficient.
Okay.
The
Try to make it efficient.
It is. It's
like using the timestamp right into a file, and anything that doesn't get written, it's as implicit zeros.
Yeah.
That's that's what you expect from a Linux file system.
Yeah. That's good. Okay.
Opus
Well,
is a lot more work, but Opus is for anything like voice. I strongly recommend using Opus. It is so much more
yeah.
compact. I mean,
Yeah.
HF, a signal from an HF receiver will usually code at about 15 kilobits per second. And signal from a repeater FM channel is about
Yeah.
20, 25, something like that.
Well,
And
we've
I can't hear the difference. So
well well, it's up
it would
to
be interesting to see if we can recover whisper signals from a Opus compressed audio.
yeah.
Theoretically,
Yeah.
it could be done. Bit
Uh,
rate's much higher than
you can't. I'm sure you can. I mean, I don't know about Opus, but I know that for a long time I was using the Kiwis, and they have by default they he has some kind of ADP, some kind of a simple compression algorithm, but
yeah. Well, I mean, I can
um,
listen to a whisper signal. I can hear hear the tone wobbling. So, in principle.
I'm sure it would work. It's
I don't know how it
um,
would do an interference, though. That would be because one of the things that sound
yeah.
codecs do is suppress signals that are next to strong signals because you can't hear them. It's called masking. So it would probably get confused, though, if you had a lot of signals on top of each other. It wouldn't do as well as if you had PCM. But what I want you to do is to start thinking about float 16. If you're going to do floats, then you do especially if you're going to do any kind of archiving of floats, you really ought to consider float 16. That's why I wanted to try a
Well,
test where we run everything
yeah.
through float 16 and see if it
Okay.
changes
Yeah.
the code rate.
Yeah. I mean, the thing is that the way the files are currently stored, it would not make any difference in terms of long-term storage. I mean, the only place that would make a difference is in 16 would be in the ham-size grape database. That's the only place where these files. So it the the question really is more for the scientists,
Well,
because
I just don't want to throw away a 2-to-1 space difference for no reason without at least looking at it.
well, it's up to Bill Engelke and the guys who own that database, because they're the ones who are
16-bit floats are
trained.
becoming pretty popular for a lot of important applications, especially
Well,
AI
well,
and
it is again. You
graphics.
need to talk to the radio scientists. I mean, the Phil, no, his name at MIT, Phil.
Erickson,
I forget his last name. It's anyway.
the radio astronomer,
Erickson, yes, Phil Erickson would be the
Erickson.
person to
Yeah.
ask. Yeah.
Okay.
I would ask Phil Erickson what he thinks about Int16 versus.
I'm a little dismayed that the support for Float 16 isn't wider. I mean, tools like SOX don't seem to understand it. It's just a shame. And there doesn't seem to be a standard wave file, type number for it. I'm a little surprised by that because, Float 16's gotten everything these days.
Well, it's I again, it's not really something that I can make a decision about, but it doesn't make any. The 32s work just fine. I'm converting everything over 32s into 16s to feed it to Whisper D. But other than that, those files don't live for more
Yeah.
than 5
Yeah. And
minutes.
if I get a chance, I will look at Whisperdy and see if I can get it to ingest floats directly. Because I'm
That
sure
would
it
be.
can, because the thing it
I
does is a bunch of floating FFTs.
Yeah.
What's the amount of entropy you get for taking a float 32 down to float 16?
Well, okay. First thing you do by going to floating point is that the instantaneous dynamic range and the total dynamic range become different, right?
Right.
The instant dynamic range is determined by the mantissa. And let's see, the exponent is what, 5 bits versus 8. So you lose total dynamic range by going to a 5-bit exponent. You lose 2 to the third, 8, a factor of 8, which is, well, hey, um, that's only what, 10 dB, is that right? 3 bits of yeah, I guess you lose, yeah, what, about 10 dB of total dynamic range, which isn't much. Of course, you also lose in the mantissa, where you lose most of it. Let me see, float 16. Wikipedia article shows there's actually two formats, but there's an IEEE one, and there's one where they just truncate the mantissa and keep the exponent, which seems a little extreme to me. Okay, yeah, the IEEE standard is sign bit, 5 exponent bits, and 10 bits for fraction versus like 21. But now remember, I mean, all the stuff came from a 16-bit front end or less. Now there is some process gain when you're filtering. And now I'm giving them floating point samples directly rather than running them through 16-bit quantization. But so theoretically, the dynamic range could be much higher than the input. But is it that high in reality? I doubt it. So is 10 bits, actually 11 bits of mantissa enough? I mean, how many dB is that? Oh, it's 6 dB per bit, so it'd be 60 some dB. 60 some, maybe 65 dB round numbers of um, um, of instantaneous dynamic range, and still a huge amount of total dynamic range, whatever it is, for, let's see, 2 to the 5th.
I mean, if it's equivalent to, say, 24 bits, then that's probably better
Well,
than.
but it's not, right? It can't be, right? I mean, it's 16 bits versus 24. Something has to be worse. My point is, when you go to floating point, the instantaneous and total dynamic range diverge.
Mm-hmm.
And the question is that a problem? Now, it sounds like from what Rob has been complaining about is his problem was total dynamic range. The whole signal level the whole spectrum was going up and down every day. And that was going past the dynamic range of the receiver.
Yeah.
That
What I'm
seems
seeing,
what we're complaining about, right?
yeah. What I've been seeing is that now that I've normalized the float, and converting from your float wave files into an int, I instruct SOX to normalize to -1
Normalized.
dB.
I know, yeah, and that
And
that
SOX puts out some statistics out of it, and SOX statistics tell you about the trough, peak levels, which is of course always -1.
right.
But the trough levels typically are -35, -40. So there isn't that, I think that would suggest you're right, that a 16-bit int might easily carry the instantaneous range of
Right.
so.
Well, here well, in a float 16, it's being carried in 11 bits. There's 10 bits
Yeah.
of mantissa plus the implicit bit that you get
Yeah.
for free.
Yeah.
But the total dynamic range is still much greater than 16 bits. I think it's actually
Yeah.
about the same. Let me look. Here's some examples here. Precision
Yeah.
limitations. There's a table here called precision limitations in a Wikipedia article.
Yeah.
And it shows what happens as the numbers, get near the limit.
Well, the other thing I was curious about too is, I mean, an extreme example of this is on like the RTL-SDR, which is only 8 bits. You end up with too few bits, too little resolution, you end up throwing distortion and end up with RMDR and all that other lovely stuff.
But you can still get good results out of one if you control the gain carefully. That's the
Right.
problem. It's about doing that. But if you do, in principle, hey, you use a 1-bit A to D, right?
Well, I mean, GPS receiver. The key we use is a 1-bit A to D on the GPS receiver.
Well, the
So,
cool thing about a real 1-bit A to D is that you don't need any AGC.
right. Yeah, if you run it, if you oversample it enough, it doesn't matter.
Right.
Yeah, I did some actual testing on an RTL SDR, which is what 8 bits and at best is 7 bits actually. And you can
Right.
the useful dynamic range, sampling at 2 megasamples in a 15, 16 kilohertz FM channel is about 65 to 70 dB.
That's about what I expect.
Yeah, I mean,
Yeah.
you do
So,
two.
fortunately, it has a tuner on it and a limited bandwidth. Otherwise, some signal far away could exceed your instantaneous dynamic range.
Right. Yeah, so 11-fold divided by, okay, yeah, so yeah, and that correlates about right. If you take if you just assume oversampling gain, then it comes out a little bit less than what you'd expect, but not terribly far off. But then again, the problem, of course, is if you have a 16-bit A to D converter, you can't ever use all 16 bits as much as you'd like.
Yeah.
I mean,
Most of them are meaningless.
right.
Certainly the low order bits are meaningless. Good source of random numbers if you need them.
Well, like for example, I remember when CDs first came out, it occurred to me that yes, it's 16 bits, but if you're listening to that symphony and there's a flute playing really, really quietly, it might only be 3 bits.
Yeah. Well.
Yeah. And we're kind of stuck with that. I mean,
Well, but no, it works. I mean, if it's really
it does
quiet
work.
and your own threshold of hearing is going to be limited. Actually, the CD is not quite dynamic range of the human ear, but it's very close.
Yeah,
About 100 dB versus 120, something like that.
Yeah, but I get yeah, the floating point
In
always
many early,
is,
I really got into classical music when the CD came out, and I just started collecting lots of them. And I noticed that in a lot of recording studios, you could hear like the rumble of the air conditioning,
oh yes,
or you could hear the conductor humming.
yes, and yeah, and pages flip.
Pages flipping, but they're probably more careful about it now. But the point is that as long as the quantizing noise isn't your limiting factor, you
Oh
don't
yeah.
have to worry about it.
Well, the other thing too is unlike music, where most people do not on the quiet parts crank up the gain to the point where we hear the noise floor. That does happen on a radio.
Yes.
So
Radio stations are notorious about compressing.
well, no, well, I'm talking about it does happen on the radio we're talking about here.
Oh, yeah, yeah.
Right. I mean, I mean, it's as for instance, if 10 meters isn't open at night and 10 meters isn't open, the, the actual amount of energy impinging on it, on your 10-meter 3 kilohertz wideband signal is probably only 1 or 2 bits at best. If you were to say this amount of nanowatts is arriving at the antenna versus what your A to D converter can handle, it's
I'll
probably
tell you
only,
exactly what that is by looking at the
yeah,
N0 figure. Yeah.
yeah, and in fact it could be well under 1 bit at
Oh,
times.
this reminds me of AGC. There's something I've been thinking about for a while. You're probably familiar with my AGC, the one I put in the demodulator, the linear demodulator. It's fairly typical. There's actually no attack time because it just does it on a 20 millisecond block basis.
Okay.
There's an adjustable hang time and a recovery time.
Okay.
Right now, after the hang time expires and I need to increase the gain, I increase it at a constant rate in decibels per second.
Mhm.
And 20 dB per second sounds about right for normal use. However, if you've got a really, really strong noise speaker or something happens that knocks the gain of the receiver way down, it'll take seconds before you hear anything out of it. So
Yes.
I'm thinking I need a nonlinear AGC. How should that work?
Well, let's see here.
The gain increase needs to be super exponential when it's very low, I think.
Let's see. I ran through this when I added AGC to the MCHF transceiver years ago. I think I had a I think my AGC recovery wasn't exponential, but it was geometric in some way. It, you know, the longer it ran, the quicker it got to solve that very problem.
Actually, no, I want it to be quick in the beginning and then slow down.
Um,
When you're hearing nothing, there's no point in ramping the gain up slowly if you're still hearing nothing, right? The reason to slow the gain recovery is to keep the noise from just jumping up in your face. So I think I should probably just like almost instantly increase the gain until the noise is back up at like minus 30 or something. I don't know.
that is very jarring. I know what you mean. It's a psychoacoustic problem. But
Yeah.
as I recall, there if the decrease in gain or increase in gain, the longer it went, the faster it would go until it hit the lever, because that's kind of what you want. I mean, when somebody's talking, you know, like somebody that's 40 over you're listening to a conversation between somebody that's 40 over and somebody that's S5. You don't want the thing to, you know, you don't want the thing
Oh,
to,
you want to recover in a straight line, basically? I mean, the
well,
rate for that, or in a specified period of time?
well, I
That
mean, well, Well, the way I did it is I played with the decay coefficients until it sounded right, and I'd probably have to look at the source code. But what it was is immediate. You don't want it immediately to recover all the gain, but if you're if say you're desensed by 30 dB, normally if the signals are roughly the same amount of roughly equal, like 10-20 dB apart, it's not a big deal. It'll recover, and you might lose it might take a couple, you know, a word or two period of time, you know, how long it takes for somebody to switch over from the other one to recover.
Right.
But if somebody's like 40 over, you know, 40 over, and then somebody's like S5, which is like 60 dB difference
You
almost.
got to wait a long time before you can hear them again. That's my
Right.
problem.
But what I did was the initial recovery is always relatively slow, but the longer you kept decreasing the gain, the faster I would decrease the gain. So, so
Uh,
I mean, so the rate would increase over time. For the first hang time, as it were, it didn't decrease all that quickly, but the longer it took for the gain to go down, the quicker I would speed it up more and
yeah,
more
I
and more.
guess you could see hang time is kind of like a special case of this. A hang time is the early part where it doesn't increase at all.
Or it increases just a little bit.
Yeah.
If it varies by 10 dB, the human ear, it's noticeable but not annoying.
But
I
that
mean,
means it's going to rush up really fast at the end of the interval. Is that what you want?
well, it about has to be though. But you don't want it to. But you don't want it. There's a you don't want it to appear instantly. You don't want it to just like bang be there.
No, no. What is that rate? I mean, 20 dB per second has been pretty good for normal variations. What the problem I'm talking about is what happens when you have an extremely strong
Yes,
momentary signal that knocks it down 60 dB, and then it takes 3 seconds to recover.
right. But with the geometric increase in the rate of change, I was able to knock it down to like half or three-quarter of a second, which is about right. You don't lose more than a word or two if somebody comes right back. But
Yeah.
this is fussy to solve, because you know my OCD probably kicked in, because you know, first of all, you know, of course I had to do a delayed AGC, because so the you know, the digital world is great because you know what the signal's going to do before you get it.
Right.
Right. And so I did that.
Well,
So
I can do that over 20 milliseconds, so they always work in 20 millisecond blocks.
right. I mean, you just delay it a block or two, but, you know, act on it. You decrease the gain before or increase the gain before you have to do it, before the signal appears, which And I've had to
Well, I
fine
do
tune
it in the
that.
same block. I don't add any delay, but there's already a block of delay. I just use that.
Right, right.
It's looking at the current block and averaging the current block before it's played the whole thing out.
Right, but the fact that you have the delay means you'll never actually overshoot either if you increase the gain quickly. But it's one of those things you're going to have to just experiment with it and make it decide for yourself what does not sound too abrupt.
There has to be a right function, I mean, there has to be a mathematical answer to this that is like, you know, the way math functions show up in the real world, exponentials show up all over the
Right.
place, right? Fibonacci sequences show up all over the place. There has to be something here that is
Well, I
natural.
think, as I recall, in the source code, I referred to, in my comments, I referred to it as a ballistic. They refer to them as ballistics. The longer it was, it's like something falling with gravity. The longer it happened, the faster it went.
Well, that's just parabolic, yeah.
Yeah, and I think that's exactly what I did. And of course, I never overshot because I you won't overshoot. But
Well,
the
no.
but it was but it was a but it was a ballistic decay. If you were to watch, if you were to graph how fall, the speed at which it fell, it would be kind of like watching something falling in with
So
gravity.
it's polynomial. It's x squared times squared.
Yeah,
Well,
but
that's not as fast as an exponential. Well, are you referring to decibels or linear gain?
I don't remember. I don't remember what I was working in on this.
Because if you're using decibels, it's already exponential, right? If you
Right,
go up
right,
at a
right.
constant decibel rate, it's exponential.
Yeah, I could.
I don't think I want any slower than that.
Yeah, I could. Yeah, I don't know that. I don't.
'Cause I like to get rid of tweaks. I mean, when in a multi-channel receiver, you can't really afford to go through tweaking every channel. So I like to automate things. That's why one of the main reasons I worked on that noise estimator so much, because I didn't want to have to adjust the threshold. I don't know of any other ham receivers that have automatic thresholds. Do you? There must be some.
What do you mean by automatic threshold?
Okay, on most AGCs and modern radios, there's a threshold adjustment, right?
Oh,
And then what
yes.
that basically does is set the noise level.
Oh, under no signal conditions.
Under no signal conditions, sets
Okay,
noise
yeah.
level. Well, I do that automatically by measuring what the noise is.
Okay.
So when there's no signal, the gain goes to whatever value it takes to put the output, let's say minus 30 dBFS. And as the signal appears and gets stronger, I don't do anything until the signal reaches minus 15. Then I start decreasing gain to keep it at minus 15.
Okay.
That's for a 15 dB headroom and a 15 dB threshold. 15 plus
Okay,
15 is
yeah.
30. And that works very well. And I don't have, I mean, sometimes when I change bands, I got to wait a few seconds for the N0 estimate to recover. And then then during that time, the noise estimate is off and the gain is off, but then it recovers and it works perfectly.
Yeah, I've never actually really liked that threshold because
Mine?
well, first of all, on commercial radios, the threshold is some fixed level, which is might as well not be there if you have an antenna connected to it.
Yeah.
Because it's
I can adjust mine. I mean, I find minus 30 dBFS is a comfortable level for noise.
okay, yeah. Well, yeah, but when you talk about threshold, a lot of radios, modern radios, I think they have a artificially high threshold to make the radio sound quieter.
Oh, yeah.
One thing you hear people talk about is when they review a radio, like this radio has a really quiet receiver. No, you're just listening to the
No.
fact that the AGC makes it sound like it's quiet. It's not
Yeah.
really quiet.
But that also means you're going to miss weak signals, right? If you're not careful.
Right. So, but in any practical sense, if you're getting an S meter reading at all, you're probably above whatever the threshold is on an analog receiver.
So
But
it
the other
means
thing,
that if you're a weak signal operator, you have to be able to hear the noise floor.
oh
Otherwise, I
yeah,
mean, with
absolutely.
a spectrum analyzer, you always want to adjust it so you can see the noise floor.
Right. But in, yeah, let's see, well, in your, I don't know, does in K9Q radio, does it have like a fast and slow AGC? Like a
Yeah,
fast
yeah.
AGC? Okay. I've
Oh well,
really,
no, it's not. There's not fast and slow. You set the recovery rate to whatever you want. That's how you can change it. You can
okay,
also set the hang time to wherever you want.
okay. I couldn't remember if that was in there, but
The
yeah,
defaults are 1.1 seconds for hang time and 20 dB per second for recovery rate, and
okay,
15 dB for threshold.
okay, yeah.
I made them defaults because they work for me, but you can change them.
Yeah, I'm trying to find, oh, there it is. I'm just,
And it works very well for like listening to a roundtable sideband QSO where the signal segments are very different.
oh yeah,
The only place where it doesn't work is if there's some very strong transient that pushes the gain way, way down, then it's silent for several seconds until it
well,
recovers.
well, the fix for that it has traditionally been is to have a limiter on your AGC detector.
Well, that's what I was saying before. I mean, I could instantaneously raise the gain when it's pushed way, way down, and suddenly there's no signal at all. I could go much faster than exponential because exponentials are famous for growing rapidly later on. They're not so famous for growing slowly at the beginning, right?
Right.
And that's why it takes so long, right? You're waiting a long time for that exponential to get going. Or another, well, looking at here in decibels, it's a linear scale. Once you talk about decibels, it's just pushed way down. If it's down 60 dB and it has to recover at 20 dB per second, it's going to take 30. It's going to take 3 seconds, which is a long time.
Right, right, yeah. I mean, but there's a difference between having a transient event that desenses the receiver and recovering from a California kilowatt that's next door to you.
Well, either way, I mean, you need to reduce gain while he's there. I mean, you don't have a choice,
right.
or he's going to clip. And then you want like the recovered gain after he goes away quickly, but not annoyingly.
Right, right. Yeah, I'm just trying to figure out where I can.
And maybe what you should do is just vary the amount of time that you have after the signal, the time you're going to allow for the gain to recover. Maybe that's what you should do. So the rate of recovery depends on how much gain you have to recover.
Well, I guess you have the advantage of knowing how much gain you need to recover, right?
Well, yeah. Yeah, I do on a block by block basis, sure. I have a hang time, so that it doesn't kick in right away. It's annoying to have it pump up between speech,
Oh yes,
that's why the hang is there, is for
yeah,
sideband.
I despise really super fast AGCs
Yeah,
actually.
and also for CW, you don't want it recovering gain. Maybe you're doing break-in or something, but you really don't want it recovering between dits or
Oh
between
no,
characters.
I despise that.
Yeah, me too.
Let's
Yeah.
see.
So you want it to come up after the signal has actually gone away. And so
Right.
what I guess you could do is, hey, here's a project. You do a big statistical study of all the signals on HF and their characteristics, the probability that they're going to come back after a certain amount of time that they've been away. You can model that, right?
I think you're overthinking it, but it would
You
be
could
interesting
really, really
to.
get into it. Well, I've seen other people. There's a guy in Sweden who's wrote exhaustively about some SM5, I don't remember his name, who's wrote exhaustively about AGC, and he has really strong opinions on how this should work. And thoughts on what the DSP people have been doing with AGC that he doesn't like. Well, I agree with some of them. He says a lot of people write SDRs seem to think that you can't ever let any sample clip for any reason, and you
Oh
have to
no,
immediately reduce gain, and you don't need to do that.
yeah. When I was working on the MCHF, I discovered that quickly. You can have quite a few. You can have quite a few samples clipping before you actually can actually notice. But the same damn thing happens on an analog radio too, because
Yeah,
it does. It's a different type of clipping. But
yeah. Well, that's his point. Is a lot of analog AGC circuits already take this into account because they have a limited dynamic range. They clip really strong peaks and don't respond to them unless they're lengthy. So I do that. I mean, the way I solve that problem is everything is based on an integration over 20 milliseconds. I don't look at the individual samples. I look at the energy in 20 millisecond blocks. 20 milliseconds is long enough that, a short burst is not going to contribute too much energy. 20 milliseconds is 50 hertz, and the human brain hearing system seem to operate at about that rate. The rate of syllables and speech,
Right.
the rate at which, I mean, obviously you hear tones higher than that, but how about the modulation of those tones, how they change? That operates
Yeah.
at a much slower rate. So that's why voice codecs usually
Yeah.
use about 20
Yeah.
millisecond time.
I read the David Rose explanation of FreeDV and
Oh,
and
I
other,
should read that.
yeah, and he talked about that very thing. Plus, I'm old enough that I experimented with the phoneme voice synthesizers many years ago, if you remember those.
Yeah.
And that's, I mean, yeah, we can only, I mean, yeah, I know what you mean. I'm looking here at the
So yeah, it's probably related to the human persistence of vision, right? When you play images faster than about 20 hertz, they fuse and become fluid. So it might be the same mechanism in the brain. Right? 20 milliseconds seems to be an important number.
I'm just okay. I just finally brought my I just found my in my MCHF my AGC code. I'm just trying to figure out what the hell I did.
Yeah, I'd like to know. I mean,
Below the name.
Are you averaging samples? Or are you You're probably not responding to individual samples because that's
Well, I mean, I'm averaging in the sense that I'm already operating. I mean, if you're operating in a sideband bandwidth, you've actually limited your slew rate tremendously.
Well, yeah, but I mean, because my receiver is works on blocks, it's a fast convolver. Everything works on chunks that are 20 milliseconds long. It's very easy for me to just look at 20
Oh,
millisecond averages.
yeah. Although it's hard. Well, I did a sliding window, but my AGC was in a sliding window.
Oh, I have more memory than that. I mean, obviously I have a gain variable,
right,
which essentially gives you that sliding window over time. But it's driven by averages that are taken every 20 milliseconds, and what the actual gain changes over seconds.
Right, but my point is that but I mean you don't actually have a sliding window available if you're operating it on your blocks, right?
No, I don't use. I mean, I could add one, but no, I don't use
yeah,
one.
because I mean, this is looking at demodulated samples. So it's what you're looking at is always some time temporarily ahead of what is going to come out the speaker, and it's always by the same amount. But you're kind of doing chunk,
right.
And I can see that might make it a bit less smooth, if you know what I mean.
Well, you'll notice that when I actually change gain, I don't change it abruptly for every block. That was noticeable. The stair stepping was actually noticeable.
Right.
So when I need to change the gain, I decide, okay, this is how much gain I want to have it at the end of the block. And then I compute take the root computation in order to figure out how much I have to apply per sample to the gain. And I do it per sample, which might be a little excessive, but it doesn't seem to cost too much.
Okay.
You have to be very careful about numerical errors when you do this because you're very close to one.
Oh, okay. I'm just
you're going to do it in every sample.
Okay, okay. So
I can correct at the end of the block. So block by block, the gain is changing in a straight line. Well, actually, a straight at a straight rate. Yeah, because I'm doing it a multiplicative, so I can't change the rate is going to be some number of dB per second during each block, and it can change at the next block.
Okay, so I mean, this is the AGC algorithm.
Oh, this is yours. This is yours.
Yeah, the one that was in the MCHF. It's
okay,
it's open source, but yeah. so So you can see the AGC value is simply multiplied by whatever the buffer is to get
What's in it? I mean, what do they represent?
audio samples, 16-bit audio samples.
So you're taking the absolute value of what?
Of whatever the audio is, because that's
Yeah.
Obviously.
Yeah.
And
Times.
multiplying it.
Oh, times the agency value. Oh, okay. So you're multiplying it into the all right.
And this is floating point, actually. This is all floating point. I mean, we come up with 60. I mean, so there's another AGC. There's a front end AGC that's before this. So we're not doing all the AGC in the 16-bit value that comes out of the A to D converter. So
This is not multi-channel, so you can do that. Okay.
correct. And you can see here, this is the gain increase for decay. And you can see it's additive. It gets there it is. You can see it adds on to itself. So this, since the value itself is added to itself, actually they're both, it becomes geometric. But anyway, it's
I'd have to tell you, it's not really obvious to me what's going on.
AGC decimation scaling. What the hell is that? Oh, I know what it is. I decimate the audio prior to processing, and that causes the skewing of gain value a little bit.
Because the sample rate has changed.
Yes, and that's what that takes into account. So that can be ignored if the sample rate is constant. So, but anyway, but yeah. So this is a ballistic increase in gain. So just the more it increases, the more cycles chunks through this thing, because this gets called.
That is a linear gain value. So is it a float or a double?
It's probably a double. I don't know what it is.
Okay.
It's a float 32.
Float 32. All right.
Yeah. It's like down there.
It's got plenty of range. Yeah.
Oh yeah, there's ton of range. So yeah, that's what I do. This operates on the audio buffer. It comes in chunks because it just spits it out. But it's contiguous over time because these values are global in the sense that all these values the next chunk continues on for whatever this doing is whatever. And so the more times through the loop, the bigger the change is. Every time it increases the gain more and more and more and more.
Okay.
But it says increase.
It's super exponential. Then it's faster than exponential.
Eventually, but it ramps up. I mean, it's like, as I said, it's like the ballistic. It starts out slow, then increases very rapidly.
That's what's confusing me. You say it's geometric, but then
I mean
ballistic is just parabolic. It's polynomial.
Well, kind of. Yeah, but I didn't. Well, you can see it's
unless you mean it's parabolic in decibels.
Well, this is a linear number. I mean, this is just.
I mean, it looks like a linear. I don't see any logs here, or so.
No, but you see, this number gets multiplied every time it goes through the loop, so it grows geometrically, as it were. Whatever.
Geometrically or exponentially.
I guess wouldn't the difference be the exponent?
I think. Let's see. It depends on its own value. So that's its exponential. That's exponential.
That's probably that's probably right then. Yeah.
Yeah, that would be a constant dB per second, which seemed intuitive to me because dB is what you perceive as loudness, right?
Right. Yeah.
So to constant dB per second, it sounds like a smooth increase in.
Although I never did the math. I never did the math to find out if those values in there to do that were greater than. I mean, it probably. I don't know if it was greater than a dB per second or more. I mean, you could actually have.
You didn't work out the rate. Yeah.
The rate. I think the rate changed, so it probably. You know what I'm saying, but
yeah.
One of the things that that has always annoyed me about analog radios is that the AGC, the gain through the IF system is often related to the diode current of the pin diodes doing the attenuation.
Yeah.
What that means is that your AGC time constant effectively changes depending on how strong your signal is.
Yeah.
Because X number of milliamps difference on with a low diode current is way different than X number of milliamps different on a high diode current.
Yeah. All you see is just go away with DSP. Isn't it great?
Right. Yeah. So a lot of radios, you've probably noticed, and it drives me up the wall, is that strong signals seem to have a much faster time constant on the AGC than weak signals in many radios.
Yeah, you don't really want that.
No. One of the worst offenders for that is the FT817, but a lot of modern radios do the same thing. So what that means is I often turn on the attenuator just to get the signal weaker so that the time constant is shorter, because I really hate fast time constant.
Fast decay. Right. Yeah, I agree. Oh, you want to talk about S meters? I have an idea of how a new S meter ought to work. I'm not going to try to fix the S meter. What I want, if I'm going to do a graphical display, I don't know how to do this because I don't do GUI programming. If somebody wants to do this, it'd be great, is to have a scale. If you're going to emulate an analog meter display, have a rotary scale that's calibrated in decibels that rotates with the noise floor. So the noise floor is at the left stop of the meter, and then you have a needle that deflects above that according to the current SNR. What do you think?
I guess it all depends on what you want the SNR to tell you. I mean the S meter to tell you, but yeah.
Oh, it's SNR. I mean,
yeah.
It always calibrates itself the noise source. The noise floor is always S0, so to speak, on the meter.
Right.
But the thing is always in decibels, and you can actually read the decibels off. The S meter always confused me. Well, first of all, it usually doesn't do what it says, but why is only half of it in decibels?
I added roughly the similar thing to the Web SDR, the one that runs on KFS in northern Utah. But what it does is that there's a sliding window that's, I think, 2 seconds long, and it gives you the apparent SNR, and all it does is look at the floor and the peak, and it kind of tells you what it thinks the SNR is.
Yeah, that's basically what I'm doing. I just want to show it
Right.
graphically. But I mean, this would be a real reading. I mean,
right.
The position of the needle would directly go into a signal report, right? I mean, how easily can I hear this guy?
Mm-hmm.
The only question is, how much averaging do I do on a sideband signal? Because I actually don't know how. Right now, I'm not averaging much.
Well, one of the things I also added, here I go again, is was on the. I had a similar problem. So if you go to like the Utah SDR and KFS, you can actually do signal graphing, S meter graphing.
Yeah.
And one of the original one that Dr. DeBoer put in there was just. I mean, if you were looking at a sideband signal, it's just noise because it was doing spot sampling of the S meter, and you kind of had to look at this fuzz on the graph. So one of the first things I added was similar to the S meter with exponential drop. So it would hang in there so that between average syllables it wouldn't drop appreciably. So you end up with this graph that was less noisy, but it would also respond relatively quickly if switched to another station, because it had to hang in there long enough. And that also used an exponential drop. If you go there and scroll down, you'll see with peak hold or something like that. And it does the same sort of thing you're kind of describing. And I think I probably stole the algorithm from the AGC, because it worked before with audio. Why shouldn't it work visually? And it's interesting though. I mean, it's still a pretty ugly graph. But the thing is,
we have so many degrees of freedom in digital signal processing. You don't know what to do.
Right. And if you're not in a big hurry to get the result, if you're not in a big hurry to get the result, you could make it a lot better. You know,
Yeah.
like, yeah, I chose to only have like a second or two a window, but if you're talking about a 5 or 10 second window, then have some intelligence to know when that signal actually has gone away to reset it.
Yeah.
That,
Well, I mean, that's what basically Rob has, using socks. I mean, he's got a non-causal AGC, and that's perfect for him.
right. Yeah.
I can never satisfy what he wanted in real time. No way.
Yeah.
I know. I got to go eat.
Yeah. Along similar lines, one of the things I experimented with one time was, you're familiar with the analog devices AD8307. It's the log amp chip. Maybe you've seen it.
I think I know what it is.
It's an 8-pin chip. It's good for about 80 some odd dB down to maybe negative 80 dBm, up to about maybe plus 10.
You can use it for like a decibel meter or something.
Right, but one of the things I did experimentally though was made an AM detector off it just by AC coupling the output of it.
Yeah.
You don't need an AGC. It's a bit distorted, but
yeah, I guess you're right. Yeah.
yeah, I mean, you don't need, you don't need an AGC. It's AC coupled.
That is the AGC. Yeah.
That is. It's yeah.
Right.
The capacity, the DC blocking is effectively doing it, and to reduce the distortion, all you need to do is put like a 1 transistor anti-log amp in there that's good for 20 dB, and you can cut the distortion down from like.
Oh, you're removing the log part from the AC component of the.
Correct.
Okay.
Although it sounds surprisingly good if you don't bother doing that. I mean, you can tell it's a bit, not hi-fi, but it's not terrible.
Yeah. Well.
Yeah.
I listened to VK5QI's QESDR a couple nights ago, tuning around on their AM broadcast band, and it was like I'd gone back in time. They're playing music, they're discussing sports, they're having sane news discussions. I mean, it's like what it used to be here before the right-wing nut jobs took over AM radio and made it a wasteland.
Right. Yeah, and you listen on some of the European AM. Well, a lot of the remaining AM transmitters in Europe are government radio networks, which have a lot of music and just discussions on like the BBC. So,
like the BBC, yeah.
Yep. Anyway, well, I better let you go and have your dinner.
Yeah, I need to eat. I haven't eaten yet. It's fun. This is always fun. The informal discussions are.
You're not by any chance going to Quartz Fest, I guess.
The site? I don't know. Are you?
I am. I've been there. I've been there past a couple of years. I ran across. What is it? 19th through the week of the 19th, I think.
I better get going if I'm going to do anything. I mean, I think Hamcation is also coming up in February.
I don't know. That's on the other side of the country.
I went to it last year.
Yeah, well, I don't fit in airplane seats.
I do. It's just they're just uncomfortable.
Yeah. But I ended up. I visited. I sat in an airplane for a few hours, and when folks live back east, and when I got to my folks' place for Thanksgiving, I immediately had to make an appointment with the surgeon to fix, because I ended up with severe tissue damage and necrosis from being crammed into an airplane seat.
Yeah, airline travel is dehumanizing, I know, but it's the only way to get around longer distances. Like if I want to go to the East Coast with my family, there's no choice, really.
Yeah, I mean, I'm 6'4" barefoot, so you can imagine.
I'm 6'4" also. I'm 6'4".
Maybe your legs are shorter than mine. I have to sit.
I'm just used to it.
I have to sit cross-legged, because except in maybe Business Plus on Delta, the distance between my backside pushing against the rail in the seat and pushing against the seat in front of me is less than the length of I physically don't fit in there.
C pitch is ridiculous. You can't use a laptop in a coach seat anymore. That's for sure.
Right. So
next to you is empty, which is rare.
So what I have to do to sit in those seats, I have to cross my legs right at my shins and try to cram them under the seat in front of me.
Right.
And then I have to sit absolutely straight up. But I got to remember.
Do that for hours. Yeah.
Yeah, you can't do that for hours. And so I learned the hard way that when I'm flying an airplane, I have to load up really heavily on anti-inflammatories before I do it, and blood thinners.
I
So,
found noise canceling headphones seem to reduce a lot of the fatigue too, especially if you're in
oh
the
yeah,
windows.
yeah. I have rather poor hearing, so I can ignore that. So,
Well, I can ignore it too, but I find it's still fatiguing.
well, I listen to music or something anyway. So
I'll put them on, turn them on just to get the noise cancellation. Even if I'm not listening to anything, I'll just keep them on.
yeah. But anyway, yeah. So yeah, I'm gonna drive down to St. George, Utah on the 17th, and then on to Courtside on the 18th.
Yeah.
Get
We've been
down.
to St. George's. We did a road trip to the eclipse in 2017 through St. George's, stopped at the Dinosaur Museum there.
I've never done that. I have a friend, KV7V, who lives down there, so it's about a third of the way there from Salt Lake.
Yeah.
It's about a
Yeah.
4.5 hour drive.
Southwest
from here.
corner of the
Yeah.
corner of the state. Yeah. It's
And then Courtside is about another 7.5, 6.5.
it's infamous for being the spot of where a lot of fallout came from one of the nuclear tests and poisoned
Oh,
John
yes.
Wayne and a bunch of his
Oh, and
movies.
that movie, it's considered one of the worst movies ever made.
Yeah.
John Wayne, the
Most
lady,
of the casting crew died of cancer.
let's see, Agnes Moorehead was in that one too. It's the one that played Endora on Bewitched.
Yeah.
Trying to think of the name of the. I don't. I know what you mean.
I know the one. Yeah, it's infamous. Yeah.
It's so bad it's good. You know, the movie, I've heard it described that.
Yeah.
So anyway, but not as bad as Monos, Hands of Fate, or Plan 9 from Outer Space.
Oh God. Yeah, well, they're in the category of it's so bad it's good. Like the Spock's Brain episode of Star Trek. You know, everybody trashes that one. I think it's kind of fun.
Oh yeah, I mean it's about as bad as almost every episode of Lost in Space was good, right?
Oh well, Lost in Space, it was actually halfway serious in the beginning. Then it just became
Silly.
the Will and Robinson and Dr. Smith and Robot show, and it was just
Yes. Yeah.
really
You're
stupid.
right. The
Yeah.
first half season, Black and White, was kind of serious. Yeah.
Yeah, at the end they had, characters walking around in carrot costumes and all sorts of stupid stuff like that.
Yeah. Yep.
So,
Anyway.
after Star Trek went off the air, it was a real wasteland.
Yeah, yep. All right.
Now, too many Star Treks. See you later.
See ya. All right. I'm gonna
Bye.
go away. It's 11 here, so 7:03.
Good night.
Bye. Bye, everybody.